So a warm welcome to everyone. Welcome to Scicloj's meeting on Clojure in geography. Just briefly, Scicloj is a community initiative to promote scientific programming with Clojure. And we are doing these meetings as a means of achieving this goal. So for those who use, for those that use the tools that others create, we hope that you all will join and be able to learn something. And for those that create the tools, we hope that this time can be a time to gain good feedback and understand user challenges. So some quick introductions of myself. My name is Zachary. I'm an aspiring Clojure developer in my final year of uni in Singapore, looking for a job in Clojure, hopefully next year. Yeah. And just quickly, my exposure to GIS is with regards to like my internship from last year, where I was working in Singapore's urban redevelopment, basically Singapore's land planning authority, and they have this internal GIS visualization platform for their planners. So today I have with us Will Cohen, who's the author of Aurelius and Ovid, which he'll probably be going through later. And he's also a huge contributor to GEO, which is a unification of 5 open source JVM libraries, geospatial libraries. So just some things to take note of. I'd like to inform everyone that this meeting will be recorded and this meeting will be uploaded onto YouTube publicly, so that's publicly available. So just to let anyone know in case for when you ask questions, it'll also be recorded. And otherwise, I'd like to invite everyone to turn on your cameras. I think most of you all have done so already, but I think it also definitely helps Will to sort of gauge whether or not any of you all are lost or particularly interested in something, so you can stop. Yeah. And if you have any questions, I think we can leave the question. We'll do the presentation first, and at the very end, then we'll have like a period of discussion. But if you have any like very pressing questions that require like immediate clarification, feel free to interrupt, or you can send a message, and I might find a better opportunity to interrupt Will. And later on, I can also help to read any questions if you all like me to do so. So just some Zoom etiquette. Just for those who are here, if you're not speaking, I'll politely ask you all to mute your mics. It's like the button in the lower left corner of the Zoom window. Yep. And yeah, so sort of mentioning just now, for today's agenda, we will be talking about the state of the geospatial ecosystem for Clojure and Java in 2020. And that will be primarily based on Will's rhythm. And once Will is done with that and what he would like to cover, then we'll enter a period of open discussion. And okay, so that's all from me. So Will, are you ready to begin?
Absolutely. So I guess before I start going, I want to make sure, is my screen visible for the presentation itself?
Yeah, we can all view it.
It's a question we have to ask nowadays with Zoom. All right, so like Zachary was saying, I'll try to keep this not too long so that there's plenty of time for discussion, because I think that a lot of what I'll be presenting also involves parts where I think you all have different kinds of experiences. So I suspect that there'll be plenty of things to discuss after what we talk about. Just a little bit about me. Some of the questions that were posed were not just about the details of specific things related to, Clojure programming, but sometimes they were about what about geospatial analysis in general, or what even about urban planning, or the connection between these kinds of disciplines. So I thought it might be useful to give a little bit of context about how I've come into this whole crazy thing in the first place. So I am an urban planner. I live in the city of Boston in the United States, and I've been working on projects related to urban planning there basically ever since I finished graduate school. So, right out of school, I started working at an urban planning and architecture firm, a private company in Boston for, about 3 years. Then while I was working there, I did a lot of analysis. I made a lot of maps, but I became increasingly interested in data analysis and software programming. And so for a little while, I left that company. I've co-founded a company called Supernormal, which was another design firm in the area, still in the Boston area, but there was a much more clear link between, architectural design and this kind of world of geospatial analysis. And that was where I found myself increasingly drawn to Clojure, which I'll get into a little bit later. The short story there, though, is that I also learned that the process of running a company is a difficult thing. And it also clarified for me that I actually want to be an urban planner, one who uses, software and data analysis. But I ended up coming back to Utile, and for the last couple of years, I've been back continuing to work on urban planning projects in the same kind of vein, but I'm still integrating, data analysis and Clojure in day-to-day work. Slightly separately, for the last 3 years or so, I've been an adjunct faculty member at Boston College at their School of Management, their business school, where I teach a course on GIS. It's to undergraduates, it's to business school students, it's to social work students. They are not they are not computer programmers. There've been a couple, computer science majors, but what it's also been for me is a weekly reminder of the difficulties of geospatial analysis for people who are new to the field. And so that lens of trying to make it easier for new people has been on my mind very much. I don't know that the tools that I've been creating for Clojure just yet solve all of that, but that's something I think is very salient for the data science community in for Clojure and other kinds of things. So I have some observations there that I'd like to put as well. So just to literally make it obvious, like that person in the red sweater there, that is me in 2015. As you can see, all the people around me are both New Englanders with their, LL Bean boots. But, on the desks, you can see a lot of paper, like large drawn, a lot of drawings. You can see cork boards with, buildings designed, pinned up all around the office, right? I am the only person at this company who does computer programming, so to speak. A lot of other people do very complicated things with computers. There's parametric design tools. There's all kinds of 3D and building information modeling stuff. But, I'm the only person with a copy of Emacs and Clojure up at the time. Although, at the moment, in 2015, in this photograph, I was actually not yet introduced to Clojure. So I was deep in the world of SQL and PostGIS, which I'll get into there. Since then, I've moved to the other side of that big room, although now I'm, of course, working from home right here since I live in the United States and things are complicated. But a little bit about, what the end product of what I do is, and I think this might be useful as context, is I'm not making websites so much at the moment. Actually, the big bulk of what I do is long processes that result in, little books of what the master plan for a community kind of is. Right off the bat, you can see, oh, this is just about community process. There's mayor's offices, there's committees. There's not computer programmers right off the bat, but there's plenty of room for analysis, right? So the first step in a lot of this has been that, before I even get to the parts of analysis, is I'm literally just going to middle school cafeterias where we have public meetings in the evening, and we have people put, green and red sticky dots on poster boards, or I go to events and we have a bunch of foam boards and I'm pointing at graphs and charts and maps to people. So a big part of my job and what urban planning is before you get to the analysis, you have to get to feedback from the community about what's actually happening in a place, right? Information that will inform the maps and analyses that you're doing. This is, a plan. The things I'm going to show you for the next couple slides are the big plan that I most recently worked on, in the last year or so. So there's still, we're all close to each other and we're not yet wearing masks, right? But there's, surveying, there's demographic maps, and there's explaining that clearly to people who have no idea what I'm talking about. Right? There's a lot of maps and stuff which ends up being sets of statistics which make their way out into charts and graphs and stuff. I can use GIS software to make a lot of these things. I can use Excel, or I could use R, or to varying degrees the Clojure ecosystem for statistics. But a big piece of it isn't just maps. A lot of it is still geospatial, right? A very simple thing right here is this map here, on the left, right? There's a set of classic land uses that urban planners talk about all the time. There's residential, there's commercial, there's industrial, there's the different general types of properties. And a big piece of understanding what's going on in a community, in a city, in a neighborhood is just that distribution. It gets a little bit complicated. There's condominiums and other kinds of legal structures that lead to multiple pieces of property stacked on top of one another. So there's actually a fairly complicated statistical set of analyses parsing these things out from one another. But the end result really is maps and graphs. And that's one piece, right? Which is where this analysis points in a certain direction. There's parts where it gets a little bit bigger. There's larger kinds of data sets that do not yet rise to the scale of big data. They're still small data, they're just bigger data, right? Stuff that is at the region of multiple states in the United States, stuff that goes back over time, things that range in the scale of many, many gigabytes of data. And in that sense, it becomes the kind of information that increasingly something like a pure GIS program like ArcMap or QGIS are unable to handle. And that's where I've been increasingly drawn to this world of PostGIS and Scicloj, which can handle scale data at that scale without blinking an eye. But sometimes the hard part is integrating that into other kinds of analyses. So sometimes it's economic, sometimes it's regional, but it's still tied to telling a story clearly for people. Which finally, the way it all comes together in the end is you come up with a plan for the future, which is really what my job is always about, which is telling a story. Here's what's going on. Here's what I've heard from the public. Here's all the kinds of analysis we've done to figure out what's actually happening in a more advanced way. And here's what we think the community should do next, or here's what the community through a more complicated outreach process kind of agrees is a good idea. In this case, we should be expanding certain industrial areas because they're doing really, really well, which is an idea at odds with a lot of manufacturing in the United States. There's areas where we should be looking for more kinds of density for downtown development. And then there's targeted places where we could do, residential, blah, 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 blah. That's where architects and other kinds of fields come into play. The architects and designers actually design the stuff in 3D. They might be using parametric tools, they might not be. And then all the stuff kind of comes together. The graphs and maps inform the design, which we then use to make more graphs and maps to kind of prove the point. A lot of this is graphical and a lot of this is narrative based. So that is to say, when I think about geospatial analysis, my lens toward this is very, very much the use of spatial analysis as an exploratory tool, right? I would be happy, and I think it would be a very productive conversation to talk at length about sort of the more large-scale data set analyses that a lot of you might be exploring in Clojure. And I think that a lot of the ways that I'm exploring geospatial data should lend themselves very, very well to that. But my draw to Lisp, originally, to learn programming and to learn Clojure has been that the idea of the REPL, so to speak, in whatever form, is actually very, very important for my career. I'm not trying to make that one geospatial analysis, which we're running 30 trillion times a second for some fancy website. It's a chance to take all these different ideas about zoning, about properties, about buildings, about open space, about whatever, the different data sets, and interactively go through a lot of different analysis to understand what's happening in a place. So in that sense, I'm still operating at what might be a fairly low level for the kinds of tools. But the friction that I'm finding there is where I've been trying to focus my efforts over the last couple of years. And sort of that's where I think can be contributing to the ecosystem best. I also am seeing a lot of where the non-professional programmer meets what I do, right? If I'm the one in Emacs, there's still someone else who sits right next to me at work who needs to do some sort of GIS. And they struggle with making more complicated analyses without necessarily knowing Clojure or without knowing the details of PostGIS. And so where I've been trying to think about doing this more is finding a way to bridge all the sort of multi-step stuff which programmers live and breathe with the way that people who are a little bit newer to it might struggle. And the final piece I just want to put out is I really don't want to reinvent the wheel. I think that's also something which I like about the Clojure ecosystem, its ethos, that there's a lot of good stuff already, whether it's the entire JVM ecosystem, whether it's all of JavaScript, or increasingly in the world of data science, whether it's R or Python. And so there's a lot of points where the ideas about what geospatial analysis should be, a lot of cases, maybe Clojure isn't the right place for certain pieces of it, which means that I really want to focus on where it does something better, which is, I think, something we could be talking about, after my presentation here. There's one other piece I just want to give as a quick aside, which is part of why actually if you've seen my focus on the Geo library and some of my Clojure library writing has taken a bit of a dip in the last couple months. It's because, you can even see from those slides I last presented, a lot of my job used to be going places in New England and the United States, talking to people at close distance and, having a lot of in-person meetings, right? That aspect of the field of urban planning has been totally upended right now because of the pandemic. Getting good community feedback from remote or via Zoom is a lot harder. And so a lot of my focus the last couple months has been out of necessity, less just the standard thing that I'm used to, going to meetings, talking to people, and making maps. And it's been much more focused on actually, how do I solicit feedback, or how does a community have one of these processes from afar or remotely? And so this is where actually I'd like to point out that the Clojure ecosystem has come to the rescue, right? There's a tool, I actually learned about it through the science Clojure community, through the data science chat on Zulip. Christopher Small, who's given a presentation in the past to all of you, he and a lot of other people have been working on a tool called Polis, which is actually a combination of a JavaScript website, but the nuts and bolts of analysis are in Clojure right now. And it's a way of kind of, by the way, these screenshots are not something I've done. They're a screenshot from a case study that was available on the Polis website in Rome. But it is a tool that allows the communities to ask questions of one another, come to consensus, talk about things. And there's a lot of very fancy geospatial, or just not spatial, fancy analysis happening using Clojure tools to come to sort of this consensus building and multidimensional analysis. It lets you think about groups. It lets you have kind of that in-person conversation, but it's able to do it via a tool and also use statistics to tell the story a little bit more fully. So for whatever it's worth, I'm actually, though my role the last couple of months in writing geospatial analysis tools has dropped a little bit, I'm actually trying to use Clojure-based tools to do other aspects of my career. So I'm actively working on doing these kinds of things, but I do, once we sort of get through this and a lot of new plans are starting, it will be a lot easier for me to sort of pick up my involvement again with the actual Clojure programming once I get back into the nuts and bolts of it. But for whatever it's worth, if you don't know about this tool, I would urge you to look at it. I find it absolutely fascinating. And I'm going to be using it in my job, so that's cool too. Okay, so I think a little bit of framing what on earth geospatial analysis is and how to use it and how Clojure fits in. It might be worth actually just doing a very quick overview of what actually is involved in geospatial analysis. And then we can see where some things already do the job very, very well and some, where there's room for improvement. This is a graph or a goofy chart that it's not perfect, but it's what I show to my students at my Intro to GIS class when I start the semester, right? These are students who are brand new to the world. They've never used GIS, or they're not new to the world. They're new to the world of GIS. And, they've never made a map before, and they may have never done any kind of data analysis. But the workflow in many ways replicates at the moment what a tech-savvy urban planner or someone working at a city or someone who's doing a lot of GIS might use to kind of do their work, right? On the one hand, you've got data, right? You've got points, you've got lines, you've got polygons, and you've got all the stuff that goes with it, right? That's really actually just GIS data, shapes and stuff associated with the shapes. It comes in a lot of different forms. It could be raster. In many cases, it's vector, right? Those are the inevitable GIS shape files from Esri that date back to the early 1990s and are truly the worst to work with, but are the lingua franca, the Word document of GIS. There's the GeoJSON, which is wonderful for web mapping, but is a ginormous file compared to a shape file and has many other downsides. There's a lot of other sort of slightly more esoteric data set types that exist, but one way or another, you have to get all these into something usable. And at the moment, the two really big tools that planners use are, a graphical tool to make maps, which is not usually web mapping. It's usually like Esri ArcMap, or in my case, QGIS, to make the map itself. Or maybe you're doing more analysis on the data. And you could either do that in QGIS, using a lot of the point and click menus, and there's a lot of sort of more advanced stuff if you want to get into scripting in Python that you can do in QGIS, or you can just bite the bullet and do stuff with database work. You can do it in PostGIS, and that is an extension to PostgreSQL that makes PostgreSQL aware of spatial data. So, from there, you have two options. You can either make the map, you can make it really fancy looking, you can, export it out to a picture, which is like the findings that you have, or you can do more analysis. You make a layer, you modify a layer, it gives you a new layer. You do more analysis, and then, that's another data set. And then you bring it back in, you put it back in QGIS, you put it back in your PostgreSQL database, you do more analysis. And it's this process of just going from layer to slightly modifying something, buffering something out, doing an intersection, making a new layer. And one way or another, what ends up happening in a lot of cases is either you make a bajillion temporary or intermediate layers that get you to where you want to go, and they all take up a lot of space in your layers window in ArcMap or QGIS. You delete your intermediate ones and you call it a day. Or you got a bunch of temporary layers in PostgreSQL or PostGIS. You find the final one you want, you can delete your little schema of temporary stuff for your intermediate tables. The reason why in many cases it becomes layer-based is a lot of times the analyses themselves require the use of other optimizations to make analysis faster. For QGIS, the process of making a new layer, a new shapefile, a new something else is there's a level of indexing that QGIS and ArcMap can do to allow you to perform an operation across the entire shapefile, across the entire data set that is a little bit faster. Or in PostGIS, a lot of times if you have these multiple steps, you oftentimes want to make what's called a spatial index. It's just like another index of a column in a table in PostgreSQL, but it does it to shapes. It puts little bounding boxes around every geometry in your table in PostGIS, and allows you to run across, massive multi-gigabyte, it could be multi-terabyte tables, and only apply your operation to the geometries that you want it to apply to. This is very, very important. If you don't have that indexing step, your spatial operations can slow down, astronomically. And so in many cases, these intermediate layers are inevitable to sort of make your workflow happen in a timely manner. Once you're done, you can either have your maps be done, you can put them together in presentations, PowerPoint, InDesign, maybe some kind of website integrating the findings, but in the end, it's data that leads to maps, that leads to information. That's kind of the field I generally work in. So let's start with, the graphical tool, right? This is very much not Clojure. One just quick aside, a lot of people might be wondering, why do we keep talking about QGIS and not ArcGIS? ArcGIS is what I was taught in graduate school. It's great. It's very, very powerful. It's the Microsoft Word of it all. It's what everyone at every, most planning firms, most cities use. And it is great, but unfortunately, it's also very expensive. And if you don't work somewhere that's willing to shell out thousands of dollars a year, or, on the old model, $20,000 or $30,000 for a perpetual license. There's different ways to sort of buy the thing. You're in a tough position. And actually, my switch to QGIS, to be totally frank, was that the place I worked it's primarily not a lot of deep spatial analysis. They had one old copy of ArcGIS from 10 years earlier on one guy's computer. And, when I was the new employee, he was like, well, you can make the maps with it, but it's on my computer and I like it. So, You can do it either after work or when I'm at lunch, whatever's really best for you, which was not so convenient. So I became highly motivated to look at open source software. And now QGIS can do, I would say 99.9% of what ArcGIS can do. It also happens to be free. It works on Mac and it is actively developed. And for those of you who are not sure about the value of QGIS versus JavaScript mapping or something else, like I am making no statement about the morality that, say, the National Security Agency does. I'm not a government employee. I'm making no statement about, the mission of things like that. But I will say that it's good enough for them. So, this is an appeal to authority, I guess. It is a shockingly powerful tool. And everyone who I work with now at the company where I work, all the stuff which, normally we thought we had to be using ArcGIS for, things which cities still think they need to be using it for, 100% transition to QGIS and PostGIS with no issue at all. So, in terms of tools and things that are good to use, there were some questions about different kinds of analyses, stuff for community gardens, how to think about doing, just the analysis on a basic level. QGIS will get you a lot of the way. Like it is very, very good. And people are committing to it, it seems like, every few minutes. And there's a solid release happening every 4 months. It is a shining star of the open source movement. So all else being equal, like before you jump into the world of Clojure, before you worry about needing to get into all these complicated things, like QGIS might actually do everything you need. It might not be a web map, but I think it's an underutilized tool for a lot of people because it feels a little strange. GIS desktop programs feel a little creaky. They crash a lot. They're frustrating to use. They don't really know what JavaScript is. It takes some finesse to make the maps pretty, but there's a lot there. So just a pitch, right? Don't reinvent the wheel. That's one piece. And for whatever it's worth, even universities are now giving formal talks at open source conferences that, QGIS does all it needs to. You can leave Esri behind. So again, another appeal to authority. This is a quick example. This is a slightly old screenshot from a few years ago, but like, just so you guys understand, you put layers in, right? This is a layer from the natural Earth data set, which is just every state and province in the United States. You add it in, it's a shapefile. It shows you the map, like it shows you the data set, and there's a lot of buttons. So this might already get you guys in a little bit of the world that's not what you want. It's graphically based. All the icons kind of look the same, and that is a downside, right? The good news is it's very, very powerful. All those buttons do what you want a GIS program to do, but you have to use this program for many, many years to begin to feel comfortable with using it, right? I use QGIS every single day. I have pretty much every single day for the better part of a decade, and I still discover new things about it every single day. So you should be, if you are making maps and it's not exclusively for the web, you might find a lot of pain solved just by using this tool, I would say. And it's available to all of you right now. I'm also happy to answer any questions about how these things get integrated, but a lot of it's there. As soon as you start using it a lot, though, you find that sometimes things get hard. Maybe you have a data set which isn't that big. Your computer's pretty powerful. You have more than 8 GB of RAM on your laptop. It shouldn't take all night to do these kinds of analyses. These are things like where you say, I want to intersect one big layer of every piece of property in a city. And Boston, for example, isn't that big a city. It's like 500,000 people plus, right? You want to intersect every single parcel with open space, something like that. That seems like it should be doable in a fairly short order. A lot of times doing it in a tool like QGIS or ArcMap, your computer will run all night on a fairly small operation. That's a good sign that you have now sort of reached the logical limit of where desktop GIS programs solve your problem for you and where the logical next step is to jump to PostgreSQL. I'm not going to give a talk on SQL today. If you want to learn SQL, there are many resources available for you all over the internet. The JVM is fantastic because of JDBC. Like, if nothing else, you can write JDBC statements, send SQL queries via the JVM to PostGIS. It will do all of your spatial analysis and it will send back your results to you. It's annoying. Maybe there's a lot of friction involved in the process of going from Java or JavaScript once I finish a port of the JavaScript geo library out to a database and back. It's not always the most preferable thing, but in situations where you have big data sets, not so big that they turn into a world of big data, but somewhat large data sets that you want to be doing spatial operations for, this SQL statement kind of sums up the power of what PostGIS is, right? You've got two tables, city and superhero, right? And the city is spatial. There's a geometry column in city, and superheroes are spatial for some reason. I'm not quite sure why. And if you want to figure out which superhero lives in which city, you can use this st_contains function in the where clause of the SQL statement. That right there is actually PostGIS in a nutshell. It's an addition to PostgreSQL. Functions that start with st_ can do spatial things to geometry columns. In this case, if the city contains the superhero, if the superhero is fully contained in the city, then that's a true one. The join can continue, and you can provide which superhero lives in that city, right? It's just like doing a spatial join, in QGIS or ArcMap, and you get back in this case, it's saying select superhero.name, so you only get the name, but you could say select superhero.geom and get a geometry return to you as well. So, QGIS plus PostGIS might solve all your problems. And all you might, if you want, need to be using Clojure for is to write the SQL statements. And there's a lot of very powerful, libraries available in Clojure right now that allow for the parameterization of, SQL statements to make this more flexible. Okay, so I've already started talking about geometry data. So then that comes into the next question. What is GIS data? How does it show up? How do we use it in the Clojure world? And just, this sounds very basic, but it's worth stating. There's really a couple different kinds of vector spatial data. You've got the simplest thing, a point, right? A dot, 0 dimensional. It exists somewhere. Then you've got lines. Lines are basically dots that are connected to each other, right? Multiple points connected together. That is sort of one dimensional. Then you have the closed version of a line where the line's endpoint is exactly where it starts again. That makes sort of what's called a polyline or a multi-line or a line string, in the world of GIS. That can be open, where it's just, still a one-dimensional shape, but it becomes kind of two-dimensional, but it's just the boundary of it. Or it can be closed. It can be a polygon or a multi-polygon where it, has an area. That's that. And then sometimes there's a world of making it, three-dimensional, but that is still kind of a not fully solved problem in the world of GIS. But there is efforts towards that in both, the sort of C world and also within, PostGIS to think about that some. And then there's all the data that comes with it, the stuff that's associated with the shapes. This blobby shape might be called the city of Austin. Maybe it has a population of 650,000. Maybe it's in the United States, in the state of Massachusetts, whatever. So you've got shapes, you've got stuff with the shapes, and they're somehow connected to each other. And all is peachy with the world, right? Well, no. And now I'm going to get a little bit metaphysical for you all, which is the idea of coordinates. The shapes have to exist somewhere. There's nothing inherently Earth-based about the idea of shapes, right? Actually, the way GIS tends to think about this is that it's Cartesian, right? They exist on a plane. There's an origin somewhere. There's positive, there's negative quadrants, and they're just there on it, right? This point could be at 1, 1. The polyline, the first one could be, the first point could be at 2, 0. The next one could be up it on the y-axis at 2, 2, and so on and so forth. And you still associate the attributes with whatever these shapes are in some form, but the next question is, okay, fine, these are a bunch of shapes on the plane, but usually GIS is geographic, it's about the Earth. The question becomes, where on Earth are the shapes? And that brings us to what is, in many ways, the most profoundly frustrating part of GIS, and something which has been a really complicated process for me, especially in integrating it into Clojure, which is the idea of the projection. If you're doing web mapping, if you're using GeoJSONs, you may never notice this issue at all. GeoJSONs really tend to require that you be using latitude and longitude as your coordinate system, right? Latitude is the sort of north and south indicator on the Earth, right? All the way up to the North Pole, all the way down to the South Pole and the equator. Longitude tends to be, or not tends to be, longitude is the vertical lines, which tell you east and west off of, the prime meridian or international date line, right? And, just one quick tip for anyone who's ever started to deal with this, you think about XY points, and then you think about latitude, longitude points. And a very common mistake is you flip them, right? Latitude, if you think latitude, longitude, that's actually Y then X. The lines are horizontal in latitude, but they're talking about the Y dimension up and down. And so even if you're just thinking in latitude, longitude, sometimes you're thinking about things in the XY plane, other times you're thinking about things in the latitude, longitude field, and there's already this idea of thinking about coordinates relative to one another. That, in a more complicated way, is the world of the projection, which is really getting the three-dimensional Earth, which is spherical-ish, onto a two-dimensional plane. And so the best way to think about it is the idea of different maps that we've seen, right? Back in the day, back when Europe was busy drawing lines across the Atlantic Ocean to conquer the New World, the Mercator map was a particularly productive map projection to be using, right? When you stretch out the Earth this way to get it, from a three-dimensional ball to a two-dimensional plane, if you stretch it out this way, the Mercator projection, straight lines on Earth are straight on the map. This is really, really good for sailing a boat across the ocean, right? The downside to this, of course, is that size becomes drastically distorted. There's always a give and a take. The catch to the projection is you can have certain things be good, but other things get distorted as you go from 3 dimensions to 2 dimensions. In this case, the orientation of lines stays good at the expense of other things. Maybe you don't really need to be conquering the rest of the world. So you might want to use this one, right? You're going to unpeel the Earth like it's a globe or like it's an orange, right? It all stays relatively contiguous. Actually, this would be a very, very bad map for crossing the Atlantic Ocean. But what happens is you're able to both preserve area very, very well, or and you're generally able to have the orientation of land masses be good for one another, but the oceans are a complete mess. So a different kind of give and take. Or maybe, if you're an American and you're used to reading old Rand McNally atlases, you're used to seeing this one for the worldwide map, the Robinson projection. This is kind of a compromise all around. It's good for looking across the world, but if you look at, countries further up in the northern or southern hemispheres, north is no longer up. In fact, north is this strange curvy kind of line. This would be a very bad map if I were trying to navigate my town or my city of Boston right now, because everything would be strangely skewed in a curvy kind of way, right? A different kind of give and take. Or when you start to zoom in, it changes yet again, right? At a continental or country-based level, there are these ideas of conical projections, where if you look to just above the United States, there's that curved latitude line. And then if you look just south of Texas and Florida, there's another latitude line. The idea of the conical projection is that within 2 parallel latitudes, both size and shape are preserved. But as you can see, they're all the longitude lines are now moving toward a singularity point at the north. And so this would be a very bad map to be looking at, at a worldwide kind of scale. That to an even broader level brings you to what in the United States is often called the state plane projection. There's really one or multiple ones of these for every state in the United States. Most other countries have similar divvying up of their countries into state plane-like local projections. This kind of solves all of your problems at a local level. This is the map that you use if you're making a map within the state of Massachusetts. North is up. Area is generally rectangular, all is fine, right? If you're looking in Massachusetts, but as soon as you zoom out, the world falls apart. The joke I say at this point, if this were a lecture to my students at Boston colleges, this is how residents of Massachusetts look at the rest of the world, right? But the key here is that data comes in lots of different projections. If you get data from the city of Boston, if you're doing data analysis in San Francisco and you want to be using municipal data sets, it's very likely that the GIS data you're getting is not in pure latitude longitude, but is in one of these area specific projections. which is totally fine. In many cases, the reason why, if I go back to this previous slide, is whoever it is that has to draw the poor buildings, every single building in the city of Boston, whatever intern at the planning department had to draw all this stuff 10 years ago and is keeping it all up to date, needs to be using a state plane projection to do it at a high level of accuracy. And the same is true for every other kind of city. So the data comes in a bajillion different projections. And so a fundamental role of any good GIS program, PostGIS, QGIS, whatever else, is to be able to navigate between all these things very, very well. If you're just doing stuff in latitude, longitude, this sounds like a lot of ruckus for no good reason. And for people who are using worldwide or just point-based data in latitude or longitude, projections don't really come up. Just as a quick aside, map projections actually even make their way into XKCD. This is yet my favorite of his series of bad map projections, the Oops All South America projection set. And in this case, he has a different kind of compromise. The projection does a good job preserving both distance and azimuth at the cost of exaggerating, the number of South Americas. So there it is. Maybe I'll start using this one in my analysis going forward. Okay. Fine, a lot of talk about projections. What is the point, right? The key is that now that you have geometries that live in some kind of projection, GIS at its most basic level takes different shapes that are on this Cartesian plane in some form of projection system and just manipulates them. Maybe it literally just modifies shapes and returns shapes. So here, right, you've got A and B. If you union A and B together, you get, a blobby that's A and B together. This is the spatial union. Maybe you take the area that's only common to A and B and you get the ST intersection, or you get the intersection of A and B. Or maybe you take, in this case, Liberty Island. This would be in New York City where the Statue of Liberty is, and you could buffer out, if it were in, the state plane, the New York State meters state plane projection, you could buffer out 500 units from this thing, which is already in a meters unit system. You could blow it out 500 meters and then get, a buffered shape. For those of you who are looking a little bit more closely at the citation for where this diagram comes from, this is PostGIS, right? ST union AB, when you run that function on the A and B column of, in this case, it would be a single feature, a single row of shape A and a single row of shape B. If those were two individual tables and you did ST union on them, it would spit back a geometry, a geometry object in PostGIS that is that shape to the left, or the intersection, the area that's common to the two. And that uses, there's a spatial library in C that PostGIS runs that does all these kinds of operations, right? It could also be predicate-based, sort of Boolean kinds of operations. Do two shapes intersect? Do two shapes overlap? Do two shapes, is one within the other, or does one contain the other? This is that thing about Gotham and the superheroes that I mentioned at the beginning, right? This is, again, PostGIS, right? You can intersect, overlap, within, contains, do all these predicates to all kinds of things, right? This is another thing about from a tutorial on PostGIS. You can see, does a point intersect with the line? Does a point intersect with the polygon? Does a multi-point intersect with a multi-line string? You can combine all the different geometries to one another. But in the end, GIS really just is the predicate-based operations. Do certain relationships exist? And when you take two shapes, can you give me new shapes? That's it. If you learn those two things in whatever language, that's geospatial analysis. You could do it in ArcMap, you can do it in QGIS, you can do it in PostGIS, and you can do it in Clojure. So the lingua franca for a lot of tools is this thing called GEOS. It is the engine that lives underneath PostGIS. It's a C, I think C++, whatever. It's a C++ port. It's a C-based library that does all that stuff. It does intersections, it does unions, it does the predicates, it understands projections. It's awesome, right? It is robust, it is mature. It's what makes PostGIS run. It's what makes PostGIS so efficient, right? It's also, if you do GIS analysis in Python, right? It's the thing that lives underneath the Shapely library, which is really the thing at the core of all GIS analysis in Python. If you do stuff in R, it's the thing that lives at the core of the SF library in R, right? So in many ways, Seems like done deal, just use that, right? That would solve all your problems. But we're lucky, right? Actually, GEOS, which is the lingua franca, is itself a downstream port of a Java library called JTS, right? I'm not going to give a tutorial of JTS here, but in a weird way, what I will just say is, at a very basic level, to your question, to the questions of how do I do geospatial analysis in Clojure, the answer is it's done. It's solved for you, sort of. JTS is in Java. It is the thing which actually is the upstream version of GEOS. So when GEOS gets new features, they actually go into JTS too, right? JTS has been around for a long, long time. It's been recently relicensed. It used to be LGPL, now it's Eclipse, and like the Eclipse distribution library, which is kind of like BSD. And it does everything. It does all the different kinds of shapes. It does all the operations. You make Java objects, these JTS geometries. They could be points, they could be lines, they could be polygons. And then you can do all these things to it. You can buffer, you can intersect, you can union. And so to be a little bit snarky, all you have to do is make a bunch of JTS objects in Java and do Java interop and Clojure, and you're done, kind of. That, of course, is very, very annoying for a lot of different ways, not least because, there's a lot of rigmarole, understandably, around JTS, because there's a lot of different things that happen in GIS. And so getting all the classes to work out with one another, calling all the right different kinds of methods, all that kind of stuff can be complicated, right? And so that's where this library, Geo, comes in. I did not write it originally. It is a very proud, ancestry. A lot of the sort of, from a couple years ago, heavy hitters in the world of Clojure who were, did at different times, stints of time at the company Factual, that is sort of an ad technology company from California. A lot of them over time put together this Clojure library that attempts to unify the JVM to do geospatial analysis. When I first started learning about wanting to do geospatial analysis myself, basically, I'd kind of learned some scheme in Lisp. I saw that JTS and this library exist in Clojure, and I knew that also the JVM, HugSQL, HoneySQL was able to talk to JDBC very, very well. And that's what helped me select Clojure in the first place, right? The ability to operate between a lot of different spatial libraries that all do different kinds of things well, to also be able to talk to PostGIS fairly efficiently, that right there seemed like the sweet spot. And so that's what led me to kind of get more involved in using Clojure in the first place. So when I first came to it, it was a slightly different thing. It unified three JVM geospatial libraries: JTS, Spatial4j, and GeoHash. That seemed very, very cool, actually. GeoHashes are a neat representation that kind of grids up the world into a set of recursive little rectangles that cover the globe that you can very quickly divvy things up into and do kinds of analysis, right? I think Factual uses this a lot to kind of quickly analyze data sets at sort of a large scale. It also could talk to Spatial4j, which is a neat library that thinks not just in terms of these Cartesian projections, but has this other idea, which is sort of the worldwide projection. What if you want to have a circle, right? JTS is point-based. You can't actually draw a circle in JTS. It's not, you can draw a thing with a lot of dots that's kind of like a circle, but not a pure circle. And particularly, you can't draw like a great circle that circumnavigates the entire globe, because JTS is plane-based. So if you need a great circle, or if you need something that thinks about the poles and goes across it all, you have to think in a different kind of way, which is the idea that Spatial4j does. Now, PostGIS has the same issue. There's geometries, which think on the Cartesian plane at a certain projection, and there's geographies, which think sort of globally. And so the JVM version of that is JTS/Spatial4j. So that seems like a very logical place to start. But a couple different things came up for me that became issues. First, this library, Geo, did not do anything to deal with projection systems, which made a lot of sense. Factual isn't a GIS programmer, an urban planner in the city of Boston. They're doing, ad and data technology across the entire globe. Latitude, longitude works just fine. They can keep it in the same projection and it's never an issue. But a lot of my introduction to beginning to, my first pull requests, my first contribution to the library became around adding Proj4j, which is the pure Java reimplementation of the projection modification library called Proj, which exists in C. It's sort of the Java implementation of it. It can reproject points from one projection to another. And with Geo 2.0, basically, Proj 4j got added into Geo, and also the understanding of the different projection systems went into Geo as well. So in addition to just having a JTS object, in JTS, there's this field for the which projection you're using, which EPSG code, which is kind of the open source numeric system that standardizes projections, which one of those things is your object in. And so with with Geo 2.0, you added Proj 4j, you added JTS, and then I also became very intrigued by this idea of H3, which is Uber's answer to the geohash, right? It's a hexagonal indexing system, which is also similarly recursive, but has a lot of other very nice features for urban planners, which I can talk about at length some other time. So that was sort of when I was working at Supernormal, that became how I started working in Clojure. But to set the stage for that, sort of take one, my first three or 4 years as a professional urban planner, there was no Clojure at all. It was just, making a lot of maps and doing a lot of PostGIS analysis. And this is kind of this, there's no map here. It's actually a really dumb looking pie chart, but it was the pinnacle of my GIS analysis after 4 years, right? And what it came to was really, parcel data, which is a very commonly thing used across the world, pieces of property for pieces of information. It's like the legal framework for how people own land. We were doing a citywide plan for the city of Boston, and needed to actually divvy up the different kinds of ownership in different ways. However, it's kind of complicated. The city owns the roads, the city owns the parks. So actually, if you just purely use the parcel information, you're not going to see parks or roads or other kinds of things. It'll just be called government owned. But we wanted to have one that's more like this chart to the right, where the parks and the roads and the airport and all the other kinds of pieces would be pulled out, which meant that it was, the spatial join. Let's take all the different layers, all the different multi-hundred megabyte, so somewhat small, but big for QGIS data sets, and do a lot of fairly complicated spatial operations on it, clipping out all this, and if you've ever been to the city of Boston, there's a lot of crazy little wiggly parks that go all through everything, like very carefully extracting out each piece of open space from every single parcel and sort of operating that, making sure that you're, doing it right. So that means first unioning every single piece of park into a mega park, kind of an Uber parcel that lives across on top of the city of Boston, and then individually differencing that out from every single parcel in the city. That's a fairly simple operation. But as I was saying before, if you're not making all those fancy indexes, and I was not, especially in 2015, 2016, a whiz at PostGIS indexes and knowing the right way to do it, I would write notes to myself, pulling out all the open space, like it'll work. Just be aware that running that SQL operation is going to take me like an hour. And actually, this is one where an index doesn't even help you, because it's just, you have to take a really complicated space and then individually difference it on, hundreds of thousands of parcels. So you do all that, you save it into one table, keep that, like spare yourself the hour going forward. And then, over the course of a week or two, talking with a lot of my coworkers, I did kind of the REPL version of SQL, where I would just write a really, really long SQL file and just one by one, run a bunch of commands, and eventually pull out all the different pieces, pull out all the open space, pull out all the airport, and give myself, the perfect graph that tells the story of land use in the city of Boston. And that became a fundamental piece of information that informed a lot of the other pieces of the urban planning and maps and analysis. But, thousands of lines of fairly naive, last minute, but just trying to get the job done SQL statements, which works fine. And for a lot of you trying to do kinds of analyses, I would actually say that GIS take one, it might serve you well. QGIS plus SQL might actually be easier in a lot of kinds of ways, if your problem is not too complicated. But sometimes your problems get a little bit more complicated. And so this is where Clojure started to play a role, right? As I mentioned before, this hexagonal index called H3, which is available in the Geo library, is a very nice way of divvying up the world into cells, right? Equally sized or similarly sized cells that are uniform, that are hexagonal across the globe. right? And so this was a different project where, this was an analysis that was done for the city of Boston to try to figure out, it was actually a question, how should we build sidewalk, or it's a cold Northern American city. We are building sidewalk, we have sidewalks every winter. There's a lot of snow. We plow everything. There's potholes. The stuff gets busted all the time. More importantly, in the winter, everyone who works at the Department of Public Works, isn't fixing sidewalks. There's snow everywhere. You can't repair roads super easily in the winter. So a lot of times, the Public Works Department would actually have their employees in the winter, when they can't be sort of doing all their major capital projects, go and grade the condition of every sidewalk in the city on a scale from 0 to 100. So they know, how broken are our sidewalks? Great. So then the question becomes, we have a set pot of money as city government to fix sidewalks. Which one should we fix? We can't fix them all. Municipal budgets are low. So the task at Supernormal was to do an analysis for the city. What sidewalks should we fix? If it were up to me, Will, the urban planner, how would I prioritize that? That's a classic geospatial GIS analysis question. So you can do a lot of different pieces, right? It was a combination of a lot of factors. We took information from the census, right? Where are neighborhoods that have historically been underinvested in, where the city has public policy interest in trying to improve the quality of life? Those are probably neighborhoods where it'd be a good place to focus. And there's a range of different demographic variables we did that analysis in. Maybe we should do bang for the buck. We should fix sidewalks that are near important things. So we found a set of assets: schools, hospitals, public transportation stops, parks, all kinds of other things. Did watershed analyses using, another open source Java-based tool that kind of does isochrone calculations, averaged those things out and found areas that are close to assets the city of Boston values. Then there's also which sidewalks are the most broken. Those are also probably good sidewalks to fix. And some weighted balance between all that stuff can lead to, this was the final product, right? Cells that from low to high represented, in our view, a balance of, a combination of near things that need to be fixed in neighborhoods where it'd be a productive thing to be fixing them with, where there's assets that, people walking on sidewalks would get to. And this, maybe the exact formula didn't make their way into, city policy, but it did cause them to rethink their process for divvying up these costs and how they thought about, fixing sidewalks in the future. The key here, though, was this use of H3, which was it exists in C, it exists in Java, it exists in JavaScript. Finding a way to actually deploy this in Clojure in a way, right? And so that's where Clojure fit in very, very well. Integrating H3 into the Geo library made it fairly trivial to just import, the city of Boston shape, polyfill it across H3 cells at a certain size, and blow the thing back out into a shape file. Now, because of all the different projection issues, because of a lot of the other issues that I'm now about to talk about that still are pain points, a lot of this analysis ended up being in PostGIS as well, which is totally fine, right? PostGIS is a very, very powerful tool, but in situations where it falls short, in this case, H3 was a good example because it wasn't integrated well, Clojure could begin to fill that gap. But I want to try to find a way to fill that gap yet again. And so this has been sort of my kind of hobby research project over the last couple of years, especially as I've been struggling with this pain point between QGIS and PostGIS and all this different kinds of stuff. So I have already been talking about indices, right? The power of PostGIS in particular is the ability to index tables and sort of cache a lot of the spatial relationships between things, so that if you're going to do intersections, if you're going to check for things, it saves you time whenever possible and goes to kind of the fastest critical path. That's part of what makes PostGIS so blazingly powerful. JTS has the ability to do these indices as well, but there's actually something else, which is something which I've been trying to think through for a while now in Clojure, which is it took me a while. I would always watch all the various talks each year from the Conj about whatever the new feature was, and it always kind of made sense to me, but I'm not operating with terabytes of data, so sometimes it felt a little bit abstract. And I would watch the talk on transducers. There were a couple Actually, there were a couple different talks about transducers, and there'd always be a metaphor. Like sometimes transducers are like a burrito. Other times it's like a speaker. Other times it's like, you know, airplane baggage. And like, it, you know, that was hard for me to wrap my head around. But eventually it kind of dawned on me that I think actually that idea lends itself very, very well to, for me, what is the biggest pain point in GIS. So I apologize, this is a fairly ugly slide. I haven't really done my best to make this totally beautiful yet, but look to the right, right? So we got two shapes, two circles. Let's say we want to get the intersection, that is to say the area common to the two shapes, right? In PostGIS, or in, you know, various versions of QGIS, that what really would happen is this dotted line would come into play. And the question is, if it knows you have two shapes, two circles, and you want to be doing a spatial operation on them too, you want to get the intersection, there's actually 3 tests that you run. First, is the small shape, the blue circle, inside the gray circle? If so, if it's totally inside, then actually the intersection's a really fast operation. You just give the inside circle, right? If the small one is totally inside the big one, and properly contained, there's no missing holes or anything, then you can just give back the blue shape. You don't have to do any new fancy spatial thing. If they partially touch, right? One, you know, the blue kind of touches the gray, but is not totally inside or totally outside, then you have to do the complicated thing. You have to do that hard spatial intersection operation. Otherwise, if neither of those things is true, then actually there's no intersection, it's just empty, right? And so, you know, that's kind of what the index does, right? In PostGIS, it will figure out these bounding boxes, these dotted lines. It will find the relationship between the two shapes and do its best to optimize to the fastest path, drop cases where there's no kinds of intersects or no kinds of contains happening. And only when it needs to will it do these more complicated operations. So that's the key. That's what we need. That's the magic of PostGIS, sort of. The indices aside, it's also that logic of moving to the fastest path. That's something which JTS kind of does. It's in there, it's in JTS, but it doesn't sort of create the path for you. JTS is a very low level library. Its job is to give you all the tools to do it yourself. So you can see right here, this is kind of my first attempt. And I really, this is where I've been sort of doing a lot of time to think to make sure I'm doing this the right way. But I've been putting this together into a library called Aurelius, which is, you know, I was reading the book at the time, Meditations. And these are my meditations on geospatial analysis for, you know, as an urban planner, right? We can actually write out an intersection function that wraps JTS that does this logic, but it uses the idea of the transducer to do it, right? So first, does the feature, let's call feature 1 the gray and feature 2 the blue. Does feature 1 contain properly? Is feature 2 totally within feature 1? If so, it's easy. We just give it the second one. Do they intersect? If not, but they still intersect in some way, that's the second level of the conditional, then we have to do the hard thing. If neither of those two things are true, it's going to be nil, right? Those are the 3 steps of it. That's the conditional between the 2 different kinds of features. More importantly, the idea of the transducer, for those of you who need to still watch the talk about the burrito, is it's this idea where in Clojure, you can sort of have operations, chains of operations that should apply to one another in a way that is agnostic to the collection that the things live inside, right? It could be a stream. It could be a vector. It could be any other kind of, you know, collection set where all the different shapes happen to. If you're going to operate this intersection, the same intersection test, in my case, you know, from the previous map, the open space difference test or whatever, to every single parcel in the city of Boston, you can kind of queue the thing up. You can take the big open space layer and you can do what's called a prepared geometry in JTS. This is a feature that exists in JTS already, where it kind of pre-bakes these bounding boxes for the shape so that you can very quickly do a contains properly or an intersects test on operations. So you can feed just one feature into the intersection function, here in Aurelius, and it will prepare one of the two geometries and set up a transducer, it will set up a one arity function, which can go into a transducer, into map, into filter, into whatever else. In other words, you can take intersection, you can take all the other JTS-based spatial operations, and using map or filter or whatever other, Clojure functions help you make transducers, you can apply all these different operations one after the other, and it will take advantage of all this prepared geometry stuff, preparing and unpreparing as is needed. What Aurelius will do is sort of put all the things together to try to get you to the optimal path for operations. So that's kind of where I'm working right now. It is an attempt to chain the different things next to one another. Now, my primary pain point, my kryptonite in a Superman metaphor once again is documentation. This is a woefully underdocumented library. I need to be writing more about it, but also part of it is it all makes sense to me because it's just me. As far as I know, I'm the only person who uses this library. And so what might be useful is to create more of a conversation around the Clojure community about where this makes sense, where there's flaws, where there's pain points. And that actually, if anything, I'm not trying to make an excuse. I do need to write more documentation for it, but I think be able to do a better job writing introductory documentation for it. If I can get some more eyes on this in the process. But anyway, this is where this stands, right? This is the big thing I've been working on over the last year or two, an attempt to take all the operations that normally I just have to put in PostGIS to make it faster, but prepare myself to be able to write transducible chains to do it in Aurelius. So over the last couple of years, or over the last year, really, since I've been writing it more recently, this is actually how I've been doing it, right? So you can prepare certain features, you can make these one arity functions, which you then create transducers out of. So for example, on the right here, this is an example of an analysis that I was doing that did this, right? And there's no map, actually, because no map was needed. This was a question related to that master plan from before that I was showing you pictures of, a thing that came out of it. Questions about the rural areas of the city. Maybe we should be thinking about densifying them. Of course, there's questions around environmental protection. There's all kinds of other policy issues, but just all else being equal, were we to change zoning and change the rules about, development in certain kinds of zones in the city, what would happen? How much new development could you be making, right? And that was where, a transducible chain came into play. First, we're going to have to filter some stuff. Take all the properties, pull out ones that are in a certain kind of zone. Next, let's filter it. So only the things with a land area greater than blah, 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 still are there, right? To meet one of the rules of zoning. Next comes the spatial operations, right? Let's take out the water because the analysis the land area or the parcels can only apply to areas that are in the land. So I would write a little function like difference hydro that was basically, that one arity function where I prepared the water layer and I said, if you ever feed this thing a parcel, it will pull out the water and it'll return you the water. So then if you run map difference water, it'll take out the waters, right? Right under it, I'll chain it to the next thing. Difference wetlands, pull out open space. And then you can do other kinds of geospatial analyses that you map one after the other. And then all this would actually do in the end, there's no maps. It was just, there was no visual maps. There was plenty of Clojure maps, right? But what it would give me is just numbers. How many things are left? How much area is left? And that was the answer I needed. Just how much area, how much was their stuff, is it worth doing? And the answer, of course, in this case was it's not worth doing. But doing this iterative, am I pulling out open space? Am I pulling out wetlands? Is the land area 80,000 square feet versus whatever square feet? Doing that in sort of my fake REPL version of PostGIS, one of those really long SQL files, would have been a nightmare. Like it would be more thousands of lines long because every one of these steps would be some chain thing of a bajillion ST functions against one another. But something about the functional level of programming, having these operations still be low level, still be kind of tied to things like the JTS intersection, but being able to chain them all against one another has proved, for me at least, very, very productive. So that's what Aurelius does for me. To make that happen, it actually required taking a previous step back, which is another library I've been working on called Ovid. You can see I was also reading some Greek text at the time, right? This is metamorphoses between different kinds of things. So the power of the Geo library is that it unifies, JTS, Spatial 4J, GeoHash, now Proj 4J, H3 into sort of this one protocol-based abstraction called the shape-like. So you can take a geometry across any one of these JVM libraries, and you get something which the Geo library can just operate on. And that's great. It can convert it to GTS, it can convert it to shape, and it can sort of think of it conceptually. So anything that implements shape-like or does shape-like, extends shape-like, can get all these things as well, right? Unfortunately, if you think back to that map where I had point, line, polygon, and attributes, for me as an urban planner, the attributes don't exist anywhere. That doesn't exist in the Geo library. It does all the operations on the shape, but all the stuff that comes with the shape, which in many cases is the interesting part, is gone. And so a huge part of, at the moment for me in Clojure, using the Geo library is I have to keep jumping in and out of Clojure maps, hash maps, right? That here's the geometry, here's the attributes. Jump into the geometry, do a bunch of junk, jump back out, reassociate it. And that became a lot of rigmarole, which is part of the whole point of Clojure, seems to be avoid the incantations of things like Java, right? So the Ovid library is actually something very, very small. It's just a new protocol called feature-like. The feature is the GIS version of a shape and its property and its attributes. So what it does is it implements a couple different, well, these are minus, so you have to actually use the function that's without the minus. To shape, to GTS, geometry, properties, and then you can change both the geometries. You can either associate a new one or update it with the function, or do the same thing to the properties, hash map field. And the point there is you put in a feature-like, you get out a feature-like. It could be just a shape-like, it could be just a geometry. You can do your operations to it that are spatial, and it'll give you back another shape-like. You could give it, a hash map with both the geometry and the properties. You can put a spatial operation onto that via feature-like, and it'll give you back a modified feature. So it's just like GIS. It's just like PostGIS, where you do the operations and the attributes stay associated. So that's sort of the main thing, which for me has solved a lot of the pain points. That's what Aurelius needs to do its work. You give it a feature-like, contains, intersects, covers, intersection, union, and instead of just spitting back another shape, it spits back a feature-like. If you give it just a JTS object, it will do all its prepares, whatever stuff, and give you back another JTS object. If you give it, a Clojure map with a geometry and a properties field, it will then give you back, a modified geometry field, and then the attributes go with it. This means that just like QGIS, just like PostGIS, I think the basic tool is there for you to perform these chains of operations, think about it spatially, or think about it where the information is associated along with it. The other big thing is the other main pain point I needed to solve right off the bat is PostGIS itself. If you talk through JDBC and you ask it some PostGIS query, it spits back, a record in JDBC, and you get some funky, binary-ish kind of object in Postgres that the geometry thing represents. So the other big thing, which is here right off the bat, is extend protocol, the readable column. Basically, if the object in one of the fields for a PostGIS result is, a well-known binary hexadecimal, which is the way that sort of the PostGIS JDBC interoperability works, then it will read it in natively to make a JTS object using the geo.io, nameset. So you can sort of if you apply the DB namespace into your, JDBC queries, basically, it will modify the next.jdbc connection so that if you're doing PostGIS back and forth, you'll get native JTS objects. Basically what that means is that the rows that we're talking about kind of feel like features. There's a little bit more work I need to do to kind of really get a good database row associated with a feature where it pulls out the right object. There's a lot of questions around which object is the actual geometry. If you have more than one, that needs a little bit of thought, but it's still a step in the right direction to kind of make PostGIS work a little bit more, the interoperability work a little bit better. So where am I going with all this? What do I want in a magical world? And this is actually not Clojure at all. This is something that, you know, I made a lot of maps for, but one of my coworkers at the place where I work did for a project, right? A lot of times you'll do some analysis, you'll make a bunch of maps, you'll come up with a story. Here's the general program that we should be putting in a location. Here's the kind of residential, commercial, whatever. And then the architects go to work, right? And they're shockingly talented at all the work that they do. They're not coding necessarily, but they might be using parametric kinds of tools. And so here's one where, you know, the planners had done their work. We're going to redevelop part of a neighborhood, you know, maybe in Somerville. Here's a vision for how it could look. But the community process needed to be around, well, I don't know, like maybe the building should be taller or shorter. Maybe there should be a different mix between commercial and residential. And so, you know, the sort of best tool right now for quick drafting of three-dimensional buildings at the architectural scale, you know, for CAD is called Rhino. And it's what you know, most of my colleagues are drawing out their sort of quick schemes for architectural design in. It's great. It's a very powerful tool. And with it is this other thing called Grasshopper, which there's a screenshot of it to the right. And for anyone who like knows the infamous world of like no code programming, it's like the holy grail thing, which is never fully solved, right? The dream that we'll be able to make some like, you know, weird connected stuff that makes people not have to write code anymore. Like it never quite makes sense, right? But actually for Grasshopper, it works. This is how architects program. They don't understand code, or some do maybe. Some can do JavaScript, some can do Python, but you know, you have to be a special soul to be an architect, learn to draw stuff, and also be able to code stuff natively. So there's actually this totally nuts tool called Grasshopper. And what it lets you do is it lets you chain all these like crazy little functions to the side that you connect together, and you can have little sliders and you can move variables up and down, and it will actually then iterate that stuff into Rhino and modify your three-dimensional buildings parametrically, your designs, right? You have to do a lot of work. Like this is I didn't zoom out, right? But like you get the point, right? There's a lot of things that are all connected to one another, and it looks like a programmer would freak out at this. This is why they would never want. That's why they write code, right? You would never draw some crazy mind map of your algorithm. You would just code the thing out. But this works better for architects if they think more visually, right? But you know, I look at this thing and I see transducers. Actually, this is the thing. This is the idea for people who are not, you know, necessarily deep Clojure programmers, who don't want to learn SQL, who just want to take multiple GIS-based steps to solve their question. That to me is the dream, that you shouldn't have to type all this junk out all the time. Maybe, or maybe you type out less of the junk, but then there's some version of chaining the steps together into kind of a path, a little formula of the analyses you want to be doing more iteratively. It is entirely possible. I never write this tool. Like, I don't want to focus my efforts on making some super fancy blobby tool with a bunch of crazy little lines, but it's the idea of it that I want to work toward enabling. It might actually be that all the time the Clojure ecosystem can stay doing it with typing out the code, and that's totally fine. But as long as in some way that dream of like actually logically moving the GIS operations through a path like that, the easier that gets, the better I think geospatial analysis can be as a profession. And so that kind of shows where I've been focusing my efforts kind of over the last year. It's been a sort of a fundamental piece that required thinking about Ovid and Aurelius, although right now, as far as I know, I'm still really the only kind of user. So I haven't even released an initial alpha release. Before I get there, there's actually another thing which ended up, you know, I optimistically thought it would be like a couple months. I was telling Daniel earlier, I thought it could be done in August. It's now October. It keeps actually getting more complicated. But the first thing I really, really want to do is finish porting Geo to Clojurescript. Clojurescript now has the bundle functionality, the ability to not have to use all this complicated externs and you don't have to use shadow and all these other things. You can just kind of more simply, in many cases, integrate node libraries into Clojurescript stuff. That's very, very powerful. And there's actually a transpilation of JTS to JavaScript called JSTS. So all that stuff from GEOS, all that stuff from JTS exists in JavaScript. I mean, it's a huge pain in the butt to use because it feels very Java-like. I don't think it's widely used in the Java ecosystem right there, but it's there. And so conceptually, it should be very simple for me to just translate the Geo library from CLJ to CLJC, just replace all the JTS interop in the JTS namespace of Geo, and have it all just instantly work on in JavaScript. Conceptually, that was what I thought a few months ago. I've now run into, there's a lot of caveats. There's a lot of small differences between Java and JavaScript. Advanced compilation is an essential piece of any good library. That has been like I've been trapped in the world of advanced compilation for the last couple months trying to get it to work, but the end is in sight. I am working on it. I've gotten a couple different namespaces going. I hope soon, whatever soon is, to get that done. And then at that point, the Geo library, all the sort of idioms of doing Clojure spatial programming should work in the world of Clojurescript as well, which I think could be very, very powerful, that you can just take the objects, GeoJSONs, whatever, and in the same way you can just do all the stuff in JTS, you can do it in JSTS and geohashes and H3 as well. So that's the big thing I've been working on the last couple months. Once I get that completed, I want to just update Ovid and Aurelius to do the same. I want those to, they won't entirely, but I'd like to get the bulk of it to also work in JVM and JavaScript so that it actually becomes not just the Clojure JVM geospatial ecosystem, but that we can add the world of JavaScript into it more easily. And the last piece, and this is on the Java side, is that whole proj4j thing. The benefit to proj4j, and the reason why it works in the Geo library, is it does most of the proj libraries, all that transformation stuff between projections. However, the world of geospatial analysts or programmers have figured out that actually it's more complicated than that. Like plates move over time on Earth. So the dot that you thought represented a point now in 30 years, if you're doing high resolution stuff, it'll move. It moves centimeters every single year. So we actually have to start thinking about projections that are time-based, that at a certain year you can calculate. There's a whole lot of levels of new kinds of functionality in the world of spatial projections, which is now implemented in the C-based proj library and is not in proj4j. And proj4j, to its credit, is trying to re-implement all of proj in Java. So it works on all Java things. But proj, the C1 now uses a SQLite database to handle all of these more complicated kinds of comparisons and projections, which itself requires native code. SQLite requires in Java native libraries to operate. So this might be an opportunity actually to just sort of take the leap and finally finish a new library that the proj project has been working on, which is this thing called proj.jni, which is an attempt to actually codify the C to write good bindings around the native version of spatial projections and write a Java library that works around that. There's a couple different steps. It needs to be accepted as a new OSGeo project if it happens. We need to find a way to embed all the different native platforms into a jar so it's good for Java users. So I'm kind of working down that a little bit too. Although I need to get back into it. But I think that is a really powerful step for the JVM, because what will mean is that the parts where the JVM falls short, where it doesn't understand all different projection systems, where there's errors, where you have to start doing weird interop with C, that's very, very painful. I think if the projections get better fixed in the JVM, then it's easier to think that many of the operations in GIS will work with less pain on the JVM. And then finally, the other big task that I know needs to happen is there just needs to be more documentation. This talk is a good start. It's kind of a ramble. There's not a lot of detail. I know that one thing I need to do is actually just really do a better job documenting this stuff, how I use it, how other people are using it, and get that clear so that it's less difficult for newcomers. So that's sort of what I see as clear next steps. Based on some of the questions from you all, I see there's sort of other directions that are good next steps too. What about big data? I haven't talked about this at all. There's the TechML dataset library, right? Which is complicated and new and rapidly changing. There's a long process of trying to figure out how to get geospatial stuff into that, right? Which is an unsolved problem. What about stuff that's bigger than just Postgres, right? There's, sort of the world of Spark, a lot of stuff on the JVM. There were, some comments about, GeoSpark, now Sedona, and finding ways to integrate that. It looks to be a very, very, very powerful tool. I'm probably not the right person to try to push that one forward just because my data isn't usually big enough. But I would love to figure out a way to have the efforts that I'm working on sort of make that easier. So I need some guidance there. Then there were also questions about mapping visualization, and sort of I would pose it back as questions for the group about when maybe QGIS is enough or when you really do need a web map. In terms of analysis, it's sort of like what I was just saying, when is PostGIS enough? When is JDBC enough, so to speak? Or when would something like transducers maybe make it faster? Or if you have to jump up a level, when would something like TechML come into play? In the world of front end, there's a lot of different pieces, right? At the moment, various users are able to use DeckGL, right? You can do stuff in the Java ecosystem right now. You can integrate Java libraries. You can use Mapbox, but what are ways that might make it better? Whether that's the Clojurescript port of Geo or other kinds of opportunities that I haven't even talked about at all. And then finally, in terms of not reinventing the wheel, there's increasingly good interoperability between Python and R. And an unexplored thing for me, at least, is when those things are already doing it better, and the ability perhaps of the JVM or of Clojure using CLJ Python or the R interoperability to sort of leverage that work. So that's my presentation. I talked for too long, and I'm sorry about that. But now we have plenty of time for discussion. I'd encourage, I'll try to stand back and let you all have questions and comments.
All right. Thanks, Will, so much for insightful talk. Right. So now we'll open up for questions. There's one question that was asked previously, which was about like the GIS workflow. He was asking, Leandro was asking about whether or not you know about Carto.com, or it was formerly known as CartoDB.
Yes, it's great. I have used it. Reasons why I haven't used it super deeply are just that it's kind of a little bit annoying to like stand up the fairly complicated piece of software entirely separately as it becomes its own kind of world. And also in many ways, I haven't found it to be better than that combination of PostGIS and QGIS, or PostGIS plus, some web mapping, right? And, some of the work that I was doing at Supernormal was a combination of these kinds of analyses that would lead to a web map without having to jump all the way to Carto and doing it the Carto way of thinking. The other, I guess, piece is if, a lot of the analyses that I'm doing, you could see it was like, I'm literally just thinking about intersections and buffers and filtering operations. Like Carto does those things, but part of Carto's magic is doing those things and providing a clear, user-friendly tool, doing it over the web, right? That does not deal with projections particularly well. That does not allow for the level of styling that maybe QGIS can do as well. And so in many cases, Carto solves a different problem than the problems that I have. That said, it's an amazing tool. And if you find that it solves a lot of your pain points, I would dramatically encourage it. Like it's great and it's good for a lot of people. It just isn't something which I personally am using on a regular basis.
I can respond to that. I can respond to that a little bit too. I've also used Carto a bit. I did my undergrad in geography, and I do Clojure now. So this talk was a lot of familiar territory. So thanks again. But yeah, I mean, Will, I'm not sure if this matches your perception, but like I tried to use Carto like a few jobs back, like back when it was still known as like CartoDB, and like the impression that I had of it was like kind of like the Salesforce for GIS. Like it's like it has like a lot of capabilities, but it also like requires like a fair bit of like work up front to like get your data into it, and like it sometimes requires like more than one person to use effectively, because you have to like maintain it.
Yes, I think that's totally accurate.
So if you're an individual, it's probably not going to offer you that much on top of like what's out there in open source and QGIS.
Yeah, I think it's true. But it's still great. Like it's very, very useful. And if you're trying to operate stuff across a lot of different people who are trying to work together on data sets, if you're trying to make something where the back end is the part that you want to handle, and you want to simplify a web-based interface to get that stuff kind of done, then yeah, I think Carto could solve your problems for you. I see a second question about how can I read Esri shapefiles and use them in Geo? You have the biggest problem of all. So turns out shapefiles are the worst. I mean, they're great. They do a lot of things, but there's a lot of problems with them. They're hard to read. There's a lot of weird reverse engineering. Geo tools and a lot of powerful JavaScript or JVM libraries handle it, but they kind of feel like bringing a sledgehammer to a knife fight, which sounds kind of violent. But I think you get my point. Another thing which I have in, I think, Ovid is a not amazing support for reading shapefiles. I started it and then got so upset by the entire process that I put it away and didn't finish it. But what I did do was I basically, it's like a shapefile namespace. I started going through the specification for shapefiles, and for a lot of them, and try for basic geometries, lines and points and stuff. And I basically did begin to implement in JVM. This is the part that maybe won't directly translate to JavaScript. And I made it so the .shp, you can read it in. There's a lot of problems. You can already hear it, right? So the problem with the shapefile, for those of you who don't use a lot of shapefiles, is it's not just one file. It actually is like 8 files that are all next to each other. There's the .shp, which reads the shapes, just the shapes, just no projection, just where the shapes are. There's the .dbf, which is all the attributes, which is an old database format called dbase3, which like you can kind of open in Excel, and like it's the sort of attribute store. There's a .prj, which is it's called a well-known text representation of the projection. So Ovid, in an incomplete way, gets you part of the way there, and it gets me just enough of the way there that I can live with it, which is part of why, unfortunately, I haven't finished it yet. So when I find myself, it's on my list. Once I finish the CLJS part, once I finish other things, I do really, really, really want to get the completion of shapefile support. If someone else wants to take that on instead, I would be happy to accept a pull request, but I do recognize it's a key. So I have I have sort of partial, yes, that's correct. There's actually, let me answer it 2 different ways. One, you can read the .shp file. You can then deal with the projection yourself and assign it somehow in the JVM. You can read the DBF using other kinds of Java libraries, and you can make all this stuff together. Now, an easier answer, you download the shapefile, you install QGIS on your computer, you open the shapefile in QGIS, and you save it as a GeoJSON. That's actually, right now, how I get stuff in. I either read in tables from PostGIS, or just at the moment, until I fix all the shapefile support, I just use QGIS to do the conversion, and then I open it back up as a GeoJSON. The question was, if it's hard enough to open a shapefile, what else should I do? And so my workaround, until I've solved the shapefile problem, is to just make GeoJSONs for them. But it is really, really important that that shapefile support be good if Clojure is going to do the ecosystem very, very well. So I recognize that as a pain point, and you're reminding me I should just eat my Brussels sprouts and finish it in Ovid.
Can I add to like the second part of your answer? I think, okay, I'm not sure about Esri shapefiles specifically, but I know there's a command line tool called OGR to OGR. And I think that's like a very common converter from formats to formats. So like,
yeah, you can use that.
Dealing with KML, yeah.
So
instead
that's
of
another
like
one. You can literally just write OGR to OGR. You can input the shapefile. It's sort of a parallel thing to QGIS. It's in the world of GDAL. I think it's pronounced Goodle. I don't even know how you pronounce it. I just call it the unpronounceable 4-letter thing, which is great. And it easily converts between all the different kinds of things. You can either do it on the command line, or if you're feeling lazy, because sometimes it's hard to remember what comes first in the OGR to OGR syntax, sometimes I just fire up QGIS and do it. But yeah, the shape file is this thing in which everyone just never wants to fix because it's such a pain in the butt. But yeah. So anyway, so I've got part of the spec implemented to read the .shp. That's pretty good. The reason why I stopped, I remember the reason why I stopped. The .prj file, the projection, when you read that in, shape files basically can define as many unique kinds of projections as they want. They don't only have to be EPSG codes. They can be variants of it. And so this is where I started down that entire rabbit hole of trying to find better C bindings to the proj library, is because to accurately and correctly read shape files in, the JVM needs to be able to correctly reproject every shape, every PRJ file into a good logical EPSG, which means that proj JNI, or like better projection support, is a prerequisite for me solving shape files. That's what it was. So I started it, I got the .shp kind of read. I realized that the projections were going to be like a multi-year nightmare, and so I stopped thinking about it. But yeah, it's on the roadmap.
All right, I personally have a question. So I want to ask, what, other than like you were saying that documentations are your kryptonite, so other than documentation, like how else can we help you in like building up this GIS ecosystem? Like you're saying, like we can also do pull requests, but I think there are certain gaps here and there that like for example the CLJ port for Geo. I'm not sure whether or not we can see your progress with that currently.
Yeah, so what I need to do is I should just like basically, okay, so I think I've mostly got it. The reason why I haven't made a pull request is I keep doubting myself, and I keep just going in circles with the internal structure, and I don't want to make some messy pull requests that's got like 5,000 commits that are just going in a circle. So that's my own shyness to actually pull the thing out there. But basically, here's what I think I've done. So now that I'm saying it on a talk that's about to be on YouTube, I hope that this will cause me enough personal motivation to actually get the pull request kind of posted. But basically, what I can do is I finalize it so that basically the weird interoperability that's unique to JTS and JSTS have to live in weird new namespaces. And I think I've mostly reorganized that. If it's okay, then so whoever would want to help is going to have to stare at some incomplete pull request, basically. But what I can do is I can make one where basically I've got JTS, I've got the spatial namespace fully ported, and I've kind of got some of the other ones going, but the tests do not pass. The main problem for doing the port also, which has been a real pain, has been that the tests are all in Midge right now, which is a testing framework in Clojure, which does not work in Clojurescript. So the port actually requires translating the entire test suite into Clojure.test. And the only thing that's worse than writing documentation is rewriting tests from one testing framework to another. So I apologize that, that's just like this thing that every time I start to do it, I always find something better to want to do. It's definitely been a factor in my not completing this pull request, but I'll at least open an incomplete one where the tests don't fully pass. And you all can maybe at least start looking at it and telling me if it kind of makes sense. And then, that at least will be functionality that exists on a branch, even if the test suite isn't fully finished yet. So I will do that. But thank you for the question, and I apologize for not finishing it yet.
I had a question about like the GEOS like JTS like connection. I was actually somewhat surprised to I mean, I think I probably previously know that that GEOS was a C++ port of JTS, but that kind of, I guess, like based on my cursory Googling, it doesn't look like like the port of JTS that's in GEOS takes advantage of like one of the most powerful features of porting to C, which is like SIMD instructions and like vectorized operations. Like I'm just like wondering like if you know of like any like more maybe other C implementations of some of these geospatial operations that maybe take advantage of like the capabilities of like modern hardware, because like with like some of the other stuff that's in the Clojure ecosystem, right? Like I think like it's like Chris Nuremberger's work, like you can hook into like the C ABI of something, and if there's like a C library out there that has like vectorized operations, you could even beat the performance of JTS from Clojure by hooking directly into that C library.
I don't know of any alternatives. I think part of it is also just that GEOS's history predates all that kind of stuff, and it's used in so many places that, and I want to be really clear, I am absolutely not a C programmer, so I'm a little bit stepping outside of my wheelhouse. But I think, backwards compatibility is a really big thing, and it is such a fundamental piece of so many libraries that my guess is anything that implements these newer kinds of features isn't going to be a GEOS. I bet. I could be wrong. It's possible that some very enterprising, smart people will find a way to fit it all in correctly. I will say that GEOS has had a fair bit of development in recent years to try to figure out different kinds of backends and allow for better kinds of analyses. And even PostGIS tries to add in things to do more sort of three-dimensional and other kinds of spatial analyses. And there's been an increase in funding for JTS because a lot of the GEOS programmers, like actually one of the sort of people who take, one of the companies that's been taking a lot of the lead on PostGIS in the GEOS world, hired the programmer from JTS, who's sort of led that up for the last, better part of 20 years, to do a better job of pushing GTS development forward to keep it in line with GEOS. So actually, there's been a fair uptick in the last couple of years of adding stuff into JTS, which has otherwise been a pretty stable bedrock kind of library. But yeah, to your point about other kinds of things that sort of use the graphics card and use other kinds of operations or more optimizations, like that is the Wild West. And if you want to take a stab at it, I think you'd make a lot of people happy. It's possible, it's totally possible that sort of what we're talking about now at a very high level of like TechML and the dataset library and thinking about spatial operations there, there's a lot of things that are very amorphous in my mind right now about all that kind of stuff. And, there's even thinking about, for example, let me take a step back, right? TechML, the dataset library, just thinking about how to handle spatial objects in it would be a major step. An entire second major step in that would be how to have it live in storage and all the different kinds of TechML libraries, right? Like TechML, or you can implement Apache Arrow with that as a way to sort of have large-scale data sets stored and sort of operate those in more efficient kinds of ways, sort of parallel to what you're talking about. And there's a lot of work right now happening in Python to try to even just think through how can we store spatial objects in the sort of GEOS world of coordinates and coordinate sequences and geometries in Apache Arrow that would kind of make sense. Like no one's even solved that yet. I do think that if they do, that'd be great because that would line up pretty well with JTS. That would mean that TechML potentially, if you're reading it, maybe could think through it, but this is not a solved problem. So it certainly bears thought. It's probably not the first thing that I'm going to be thinking of since I'm still trying to solve just like a basic Clojurescript port, but I would encourage you to take a look. It would make me happy, and it would definitely be certainly a selling point for this ecosystem.
I'm also been using H3 a lot. It's super valuable. One thing I'd love to be able to do is to figure out some way of, for a particular H3 hexagon at a particular resolution, what is the population in that hexagon? Any advice you can give me on how I could go try to solve that problem?
Yes, I would. So I can give you a guesstimate. So are you talking about the United States or elsewhere in the world?
United States.
All right, so let's say you had either all the United States or some subset of it, right? You can actually get, well, pretty soon, assuming the federal government doesn't totally collapse, we'll have the 2020 census. But in the meantime, we have the 2010 census. The census, by the way, for those of you who are not Americans, is a decennial count of every single person in the United States. They actually, you fill out a survey, or people are sent out to every individual household in America. And they ask you how many people live there and some basic information, right? And it's released publicly. You can get, for the 2010 census from the Census Bureau, a shapefile of at the block level, which is the most accurate level or most fine-grained level of census information, the population, the number of housing units, and some information about households. If you want to get better stuff about other kinds of demographics, educational attainment, other kinds of stuff, you have to go out to the block group or census tract level and do a whole bunch of sort of census stuff. But you can get, for 10 years ago, which is not perfect, but it's a start, block level data for every block in America by state. You can download a shapefile of that. You can save it as a GeoJSON, right? Via OGR to OGR right now, or eventually maybe via a Clojure library. So you have a contiguous, perfect, for the state of California, I think in your case, right? A perfect, contiguous, topologically consistent block level population count. What you can then do is, for an H3 cell, you do the intersects, right? So first your question would be, for an H3 cell, find which when ST intersects or when dot intersects in a GTS kind of way, which blocks does it cover? Great. So it'll be one or perhaps more than one, because polygons touching polygons, you might have multiple blocks. At that point, you need to kind of guesstimate what proportion of the block that the H3 cell is covering is there. And so what you would do is, let's say you had an H3 cell and it somehow overlaps 2 different census blocks. You would find the 2 GeoIDs of the 2 different census blocks that have a population. You could then, to get an estimate, you could say, okay, great. You do the intersection function, whether it's in ST intersection or in GEOS or Ovid or Aurelius or something. Here's the area that is common to both the H3 cell and that census block, and then you would need to do an area comparison. This sort of partial H3 cell on this census block is 15 or 20% of the block itself. You could say maybe 0.2 or 0.15 proportion of that block equals this many people. That would be the urban planar method to guesstimating it. If you want to get really fancy, which I bet you don't, what you could do is do another level of GIS analysis. You could download the parcel information for, I think you're in San Francisco, right? So you could download San Francisco parcel information, right? The actual property information for the city of San Francisco. You could then do all that crazy stuff I was saying about the zones and all the different kinds of things. You could find only the residential land in San Francisco, or mixed use, where sometimes you have maybe you've got your Pret on the first floor, or like a Panera on the first floor, and then there are apartments above, right? You can find all that stuff out. So you can actually get down to the property level. If you really, really wanted to get very fine-grained, you could say, find only land where residential stuff can be on each census block. So then, instead of just having a contiguous census block covering water, open space, roads, everything else with the number of people, you could even confine it to make it more accurate. Only residential land on every census block. And then you could say, if on this census block, there's 100 people, the naive version would be to sort of naively distribute 100 people across the entire census block. Or you could do all your best to get only the residential land in that census block. And then if you have your partial cell, you can be more confident that your little proportion kind of represents only residential land. For example, if that H3 cell overlapped with, just a park in San Francisco, there'd be no people. And so that would be a way to be more accurate if you wanted. But all these things that I'm saying, just for everyone else's reference, these are not fancy Carto level kinds of tools. These really are the fundamental GIS operations: intersections, difference, intersects, that kind of a thing. And so I would say that for people who are curious about how to be using these tools, it's not as fancy as QGIS. It's not as fancy as a good graphical tool, but the fact that JTS gives you all of those basic operations, your job as a smart person using these tools really is just to combine these low-level operations. If you're doing anything that's more than just the most basic analysis, you're gonna have to do things at this level. There's currently no good way to kind of not think about buffers and intersections when it comes down to it, unfortunately.
Thank you, that's super. Yes, that's very valuable. Thank you so much.
Of course.
Appreciate it.
Anyone has any questions? Just voice out.
Yeah, maybe we could talk just for a short while about visualization. What you would find, what would you find useful, and what would you dream about having on the visualization side?
Should I answer that, or should someone else go first?
I think, Will, you can go ahead.
You go first.
All right. So the first is, it was the don't reinvent the wheel. I don't want to write QGIS again. Like, that tool is amazing. If it's just basic map making, don't reinvent it. It's the best. It is better than anything we're going to write. Thousands of people are contributing to it on a regular basis for static maps. Similarly, at the moment, Mapbox GL, and by extension, sort of Uber things over it, right? Mapbox GL is a framework, is a JavaScript library that uses WebGL to make slippy maps. So it's not Google Maps, it's not Leaflet, it's this other one. And to my mind, I, at the moment, have not found a better thing. I would call it state of the art for performant web-based mapping. It does a lot of things really, really well. You can do shockingly advanced styling and visualization of base maps. You can color every single layer with all kinds of different complicated things. There's even tools called like Mapbox Studio, and there's like offline versions, and there's open source alternatives to create these like basically JSON style JSONs that can modify every aspect of the base map. Additionally, you can add in your own GeoJSONs, or you can add in your own vector tiles that you can generate in PostGIS, or kind of in Java, that you can then add on to it. So you can, via Mapbox GL, put a lot of really fancy stuff into interactive web JavaScript mapping. On top of that, there's a set of other tools that I think some of you on this call are using as well. There's one called deck.gl, which is written by Uber. It's not H3, but I think it does some hexagonal analysis. But it's not just sort of flat stuff on Mapbox GL. It's a whole set of sort of additional visualization tools that live on top of Mapbox. So between Mapbox, I think the JavaScript tools are like this sort of other, like QGIS is the best for just static maps. If you want to make a pretty advanced map across all kinds of different projections, that's your thing. If you want to make web-based visualizations that are more dynamic, that can do things in 3 dimensions, that can do things that are much more statistically interesting, Mapbox GL and DeckGL are the best. And there's no reason to reinvent them. So to the degree that you can, as a Clojurescript developer, just integrate with those two for the web, like, you're good. Like, I think that's solved, right? Or that piece of it is solved. The question becomes what else there is to do. That's what initially made me start this never-ending task of the Clojurescript port, which is, I feel like, for me at least, right now, I do a bunch of coding in my REPL. I make a bunch of random shape files or GeoJSONs or whatever they are, and I do analyses, I do my transducers, I make a new thing, I export it out, I put it in maybe I upload it to PostGIS, maybe I put it in QGIS and make a map. In a slightly alternative world where I were still making web maps all the time, I could be doing it in Mapbox, right? But there's still, at the moment, a lot of like Clojure to uploading it to Mapbox to whatever else. I think the Clojurescript port, I think, would be helpful, because it would mean that you can do some of that dynamic visualization and analysis up in the front end as well. I think that's useful. Now, I'm not a full-time Clojurescript developer. That's also part of my problem, is like, it's like I'm having to learn all the nuances of JavaScript and Clojurescript that I'm not using all the time. That's one step. But I'm not sure what else would be useful. Is it another kind of, like, maybe it's some weird intermediate between QGIS and web mapping, something that allows you to play with some of the tools. I don't know. That's a good question for you all. But at the moment, at least, I think sort of, if you find a way to get to Mapbox, use Mapbox. If you find a way to get to QGIS, use QGIS. It seems to me clear that the Clojurescript port is useful, but for me, at least, the problems of visualization, my needs at the moment are solved. And so I'm curious where else you all are finding pain that you can't solve with existing things.
So
I'm sorry, please go on.
Okay, so yeah, I make heavy use of DecGL and Mapbox. I wanted to mention another path to there, not that it's better, it's just, but it's lower weight, is that Uber also has a web application called Kepler.gl, which is a web app that runs DecGL, and it's sort of designed for people who are data scientists and they just have a data set, and you can load the data set into Kepler and hence DecGL, and then start playing around with layers and visualize that way. So that's sort of the no programming model of visualizing some data. Now, I'm making a joke about no programming. Sometimes you have to program to get the data in the right format to load it into Kepler.gl. So we did that. That's where I started. And then when we did that, it worked great. And then like, okay, this is cute, but I don't like to it didn't know anything about my domain. Kepler is just like, you've got, JSON and data and layers and this. And so I wanted to have something more domain specific. So then I jumped all the way over to DecGL and created a web application in a combination of Clojure and Clojurescript that was specific to my domain, tied into the database. So that was very, very powerful. Now the next thing, so then at some point in that whole process, the Uber people came out with a Python binding to Dec, which is like PyDec. So then you can, it's sort of an intermediate, so you can sit there in Python and then define Dec layers and it's tied in with Jupyter, I think, all that stuff. So I thought that was a cute idea, but I really want to do that from Clojure. So I've been working with a colleague on sort of the Dec. So the DecGL binding in the browser from the Clojure REPL. So the thing that you all probably know about is Oz, which is basically that for Vega. So for Vega, so in the Clojure REPL, you can pull up a browser window and start doing Vega kinds of things from Clojure. So I'm trying to do that for DecGL, and we have early versions of that are starting to work. So that's pretty powerful too. So I can throw together a geospatial visualization from the REPL and play around with it.
That sounds really cool, and I would be interested to hear much more about that as well. What I was trying to say earlier was that there is a Mapbox integration also in the Microsoft Power BI data analysis tool that lets you easily mix and match different kinds of data sets and draw a map out of them and visualize them. I tried it in the summer, and it wasn't quite sophisticated yet, but in the GitHub it looked like that it's under development, and that might turn out to be something really useful for data scientists as well. And it was quite simple to use as well. And personally, I'm very interested in these exploratory tools where you can just put your data in and try to visualize it in different ways and try to understand the data better. So that's why I was very enthusiastic about Dan, your what you said. So is that something open source you're working on, or is it?
It's planned to be open source. We haven't pushed anything up yet. So yeah. Let's say, I mean, it's not a promise, but maybe in like a 2-month kind of area, maybe we'll have something that it's good enough to push. So, but yeah, you can try to bug me later offline or something, but I think that's possibly realistic in like 1 to, maybe more like 2 months.
Okay.
Sorry to sort of interrupt. I think like the 2 hours have been reached. So like, I think someone left already. So like, I'm not sure how this will work because I think we still have like this interesting discussion going on. But in a sense, like, I guess we'll sort of close here. But we'll probably still continue the recording because these are like questions people probably want to hear. But yeah, so for now, like for those that need to go off, we'll sort of be ending the formal session here. But we can definitely continue the discussion here, and yeah. But yes, so huge thanks to Will for all this his time and effort to talk about Clojure's geospatial space and all his insightful thoughts and comments. Yeah.
Of course, and I'm happy to stay around and answer other questions as well.
Yeah, first of all, thanks for the great presentation, Will. I can already almost see in my eyes that I'm evaluating those cool, like I'm having my geospatial data and I'm flowing through the transducers and then rendering them to a web map in Clojurescript. So that's like something that I would like to see in the future happen in a very very REPL-driven way.
All right, you're inspiring me to try to finish that pull request. So I'm sorry for not doing it yet.
Yeah, let me know if I can help you with that.
Okay, I'll get it to how about this? I will get it to a point where I am right now is a good starting point. And then like, I think the main thing I'm gonna need help on is just some of those tests and just make sure I'm dotting all my I's and crossing my T's. So I'll put it there and I'll start it and then it'll be on the Factual Geo repository. And so we'll figure out a way to sort of collaborate and get that thing done. Okay, thank you.
One of I didn't quite understand where you're coming from with the feature like, but now your explanation was excellent. So now I get it, and now I'm excited about it. I think that for me, I have a different. I'm not an urban planner. I'm dealing with aircraft and aircraft trajectories. So first of all, everything's 3D, and really everything is 4D because it's got time. And I find that a lot of these libraries are not oriented toward time. So in PostGIS, there's you can have a 3D point with an M value, and you can use time for the M value. You can do a lot with it. It's not as awesome as you'd like. But then when you come back to something like JTS, I think there's no time, right? It's like,
well, so the newer versions of JTS in the factual library, like one of the changes is it's not perfect. And this is where actually backwards compatibility became a bit of a complication. I went ahead and when we added the projections and stuff into Factual Geo, it was like, let's say you have a point. You could do a point X, Y, Z, and then the SRID, the projection for it. Due to backwards compatibility reasons, like adding another arity would be complicated because if you did X, Y, Z, M, it's hard to know is the final the fourth argument time or projection. So the sort of the native geometry generation features of the Factual Geo library do not get the M very well. However, JTS now has a fourth dimension in coordinates available. They're only kind of exposed, but they're called coordinate like XYZMs basically. And you can construct geometries out of them, and you can, and so like they live inside all of the different JTS objects. So you have to be a little bit careful in the way you construct them. And also this is where I think Proj4j might be a little bit of a problem is I think when you pass your reprojections through, I'm not 100% sure that it's totally consistent in not dropping the M. And that might be partially because I don't ever use M. So actually what might be useful if you'd be willing is if you could just poke around a little bit in, like try it out a little bit in the JTS and figure out, is there any mistake? Like, did we screw anything up in factual geo where like it's incorrectly dropping M's when it shouldn't? I think at the moment, if you put M's in correctly, they're there. It doesn't lose any. But what, using Ovid and Aurelius might be a good chance to kind of revisit some of that API to get it a little bit more consistent. Like it can still live and keep backwards compatibility within Geo just fine. Like I don't want to break anything. But that'd be something which I'd like to think through a little bit more consistently before I do a first alpha release, because I'd like Ovid and Aurelius to better think about it. So there might be a little bit of a dance between Geo and the other ones, but if you could like just give me some advice or like try it out a little bit and see where a pain point is, we can get that fixed for sure.
I'll do that for sure. The other thing I'll just give you a pat on the back too is that I did poke in your library that readable column thing for the PostGIS. I actually did that because I do have I have some trajectories in PostGIS that have the time as the MBI, and I was able to read it in to Clojure. So I was pretty excited about that. Cool. That's all. That's as far as I got. But I did find this coordinate thing a long time ago. I'm still grokking the difference between a point and a coordinate because they're not the same thing.
No, it's a totally good question. A coordinate is a projectionless thing. It's just a number of, it's an X, a Y, a Z, and potentially an M that just exists in no plane whatsoever. A point is a single coordinate projected somehow, or projected with no projection. It could have a projection of 0, right? A line string is a geometry with multiple points, with multiple coordinates. So this is where you might actually need to, like, if you look, this is the GTS and GEOS kind of specification for how GIS works. All geometries, whether it's a point, a line string, a closed line string, a multi-line string, a polygon, whatever, like a line string is made up of multiple, it's sort of like a point in multiple dimensions. A polygon is like, it could be a line string with a hole. Like it could be a closed line string with another polygon kind of cut out of it, right? And each of these things is thought of internally in JTS and GEOS as a set of what's called coordinate sequences, where a point has a single coordinate sequence of 1 point. A line string has a single coordinate sequence of like a vector of coordinates. A polygon has potentially multiple line strings, which are themselves individually coordinate sequences. A multi-polygon is that in multiple different polygons put together, but deep down inside, they're all coordinates. And so the whole way that Proj4j or that Geo and Proj4j work together is basically when you reproject a point, what it actually does is it just goes through the full set of coordinate sequences embedded in a geometry and just applies the transformation to each one of them. So you should never be using a coordinate in any kind of spatial way. It's more like that's the little internal thing within a geometry. Like you modify a coordinate and reapply it to a geometry. That's kind of how projections work. So the main flaw in terms of the M or T coordinate might be if there's a mistake somewhere, and that Proj4j doesn't do a very good job of thinking about T. So I can't remember if Proj4j drops the T or not. But I do know that sort of factual geo on its own and JTS, if the T's in there, it should stay. It's only if you do something where it might be messing up the coordinates and dropping the T. And actually, to answer the question better, I'm not gonna do it right now, but if you look in the factual geo test suite, I did address this in some level. Like there's like a note where like the test is like, when you reproject, it drops the T, but when you make shapes and you turn it into a thing, it keeps it. Like whatever that status is, that's the current status. So if you like send me a message on Zulip or something, or make, whatever, we can figure out how to best address that going forward. Because it's, as time goes on and as analysis gets more advanced, it's definitely important.
Yeah, so I'm super motivated, so I'll definitely take a look at that and get in touch with you. Not that it matters that much, but you care a lot about intersects and all this kind of stuff. I get it from your work. So what the thing that I really care about with these trajectories is what's the point and time of and distance of closest approach between a location of interest and a trajectory. So like, when did this airplane come closest to my house? Okay.
Okay, so it's not intersects, but GTS has those.
So yeah, I know I figured out with so long story short, PostGIS has a bunch of stuff that's helpful for this. They have 3D closest point and things like that, and it works with trajectory. So I had to go seek help from PostGIS experts. So, but I was able to got that help, paid for the privilege, but it was reasonable. And now I can actually I have a PostGIS query that is the worst query I've ever seen that they wrote for me, but it can return the point of closest approach, the time of closest approach, and distance closest approach, which is super powerful. So I can say, like, give me all the aircraft that at any point in the trajectory came within 3 kilometers of my house, and what time did each one of those aircraft come closest, and how far away was it at the time? So that's the kind of thing I need to be able to do. And I'd like to be able to do that not in PostGIS. I mean, PostGIS is great. I'd like to be able to do it also on the Clojure side. And this is my problem to solve, but I'll think about it some more, and I'd like to be able to do some of this stuff using just Geo itself, in Clojure versus having to ship it all off to the database and do it there. Not that there's anything wrong with the database, but there's sometimes you just want to do things in the REPL.
So how about this? What your job then would be, and I'd be happy to have, I'm committing to too many things. I also have a way of overpromising, but what might be good is to figure out where JTS starts to diverge, because they are trying to increase that functionality. And so I know that JTS, for example, has 3D coordinates and 4D coordinates. So those things should be able to exist. And, if closest point, if a lot of the 2D ones exist in PostGIS, my guess is some version of that exists somewhere deep in the bowels of the algorithms in JTS for 2D. It's possible 3D isn't there. So the right step, is just figuring out where it fell in between PostGIS and whatever. It may just be adding a couple fairly small algorithms, whatever the functionality is in GEOS, to be back in JTS. And then that should work all the way back up the chain, and we should have it in the JVM. I'm happy to talk with you some more about that, because that would be good to figure out. I'd like JTS.
Yeah, that sounds great.
Yeah,
that sounds great. I'll do a bunch of work, and then I'll contact you, and you can give me some advice, and you can point me in the right direction. And I'm happy to do some work on this to support it, because I care about it. But it would be good to have somebody who, you have a lot of experience with the Geo library, which I don't have, and the internals and stuff like that. So you can point me in the right direction and say, do this or don't do that. So I'll take that action to try to solve more of my problem and come to you for some more advice. Sounds good.
Anyone has any other questions? Well, you're talking about documentation. Is there a way that would you want help with documentation for say Aurelius and Ovid? Okay, maybe more for Aurelius. Not sure if Geo needs more documentation.
I would say Aurelius needs more. Ovid's pretty small. It's actually just it's really just the feature. I wanted to make one library that's just a plain abstraction. Maybe you don't need all the fancy stuff about, all the different transducers and things. So I just wanted to create one very small library, because people might want to be able to just use feature without using all the other stuff. So that's why I made it. It's pretty small. I don't think there's that much that needs to go there. As far as I'm concerned, if you want to start poking around Aurelius, basically here's where documentation could go. You look at it, you're I have no idea why Will wrote all this. Even just saying, I don't know why, it's self-evident to me because I wrote it. So it would be helpful just to be this part doesn't make sense. I don't understand the use case. Here's some things I could try out. I would be eager to accept pull requests on this. and work on it. And so we can do the conversations in Zulip, we can talk about it, and we can make a plan. But I really do want that library to make it easier for people. Geo is fantastic. I love it. I use it all the time, but I'm trying to make it easier for planners, or not planners, but for the analysis too. And so I would love for it to get a little bit more stabilized, get to a first release, and then it get built upon as a good exploratory tool. So I guess you should come talk to me and we'll make a plan.
Right, will do.
Okay.
If anyone else other questions, please interrupt me. But another question that I'm personally sort of curious is that I'm familiar with slightly familiar with like Rhino and like Grasshopper space. But I was thinking, isn't there like a similar idea with like ArcGIS? So ArcGIS also has like sort of like visual scripting. Yeah, so does that also sort of fulfill the criteria you're looking at for Grasshopper?
Sort of. They have that in QGIS too. It's called like I don't even use that. It's called like modeling. There's like these things where you can take the different it's actually very similar to what I'm talking about, buffer and whatever, and you chain them together and you can make these little formulas, but there's major downsides. Well, they work, but there's a couple major downsides. QGIS in ArcGIS are not as performant as PostGIS. They just, single threaded operations that go one after another. There's a lot of very understandable baggage that comes with using these tools to get the stuff done. It gets filtered off, it's the part of the power I have found in PostGIS, and also with recent releases of PostgreSQL, the ability to do parallel operations, like using multiple cores to do those things, is now pretty established in PostGIS. In the JVM, very, very similar. Like a transducer written well can be parallelized across a lot of different kinds of things. And so the magic I see in trying to solve it in Clojure is that the really big operations that might still choke if they're in ArcGIS or in QGIS would be the ability to quickly parallelize them and like use your CPU efficiently to do those kinds of operations. So, that's a much harder problem to solve in QGIS than it might be were we to think it through with that, as a basic principle. And the thing is, transducers and a lot of things about Clojure set the stage for that. So I feel like it's a good base to build it on. But you're absolutely right. Those things do exist in QGIS already. They don't solve, they make for some reason, something about the use of them feels harder than it should be. But the functionality is absolutely there in some form. It's very, very powerful. Something about it feels like it makes my life harder. So I don't find myself drawn toward it for some reason or another.
All right, got it.
Maybe I wish to suggest something. Please tell me if it sounds good. So it could be nice to have some visualization way as a tool for documentation, so that we can have a certain walkthrough with some operations and see them in the docs. And for this, we may choose possibly not the best way of visualization, but one of the easiest ways, maybe leaflet or something like that. And then just try to write, maybe together, if you wish, we can meet and write stories and see if we can find out some REPL experience that is nice for doing that, just experimenting with the existing libraries and having it visual. So would you like to meet, maybe Zach or anybody else, would you like to meet and play together with the code and see if we can figure it out as a way of telling stories?
Yeah, that sounds interesting to me. Because I've been doing something like that, but it's like halfway manual and and like halfway REPL driven and so on. But I would be really interested in going towards that kind of workflow.
Wonderful, wonderful. So maybe we can set some kind of meeting like that, maybe in 2 or 3 weeks. Does it sound good for anyone who wants to? Maybe without bothering Will, and then afterwards we can tell Will if it went okay. And yeah. And any way you prefer. Yeah, thanks.
Yeah, I think like as Will sort of did mention, the documentation as for how the processes for how Clojure might be, or just GIS in general, but also like how Clojure will fit in would be great. So sort of like the user story would definitely be welcome. But I'll try my best. Like I don't know how much I can help in that sense.
I have a suspicion it's the kind of thing that sounds small but gets really, really big. Like, you know, I've started to think about this the last couple months, right? I've been teaching this course for a couple of years now to undergraduates, and I have a lot of advice. So I've got my own personal workflow for how to make this stuff make sense. I've learned a lot over the last couple of years of how people who are new to it, where their pain points are. But that still isn't even a standalone set of documentation. And as you know, this higher education is having to figure out a way to be more distance, I'm having to modify the way I think through these kinds of things. At the very even further dream than like finishing some of these small library tools is I think I would like to try my best when I find some magical set of hundreds of hours of free time is to try to put together a coherent set of some of my workflows for it. I think that is absolutely a separate project from what Daniel suggested, which is a very, very important one, which is beginning to think through these kinds of things. But I will say that it is on my mind as something I need to work on in some kind of way. Finding a way to line it up with all the things that you all are working on as well would be great too. I'm interested. It's so daunting. Trying to teach this whole field is such a daunting thing. It really is like a textbook, right? Like in the end, to that end, where's my copy? If nothing else, there's a textbook called PostGIS in Action. It is a textbook written by the writers of PostGIS. If you're actually just curious and learning more, it's a good book. Like you should get that textbook. It's not Clojure. It's not, you know, but it is an exhaustive and comprehensive look in how to do complicated, valuable, you know, well-written SQL queries in PostGIS. It's a good place to start. And in a weird way, it kind of can be some advice for what a different version that might be Clojure oriented might kind of want to be. But for people who want to know more right now, I would encourage you just to look at that textbook. It's the best resource I know right now about GIS analysis, spatially in a programmatic way.
Yeah, and I'm quite familiar with PostGIS and QGIS and these tools and so on. But I'm thinking something like having a subset of those features running in a browser, so that a non-GIS expert could make sense of their spatial data, and that's something that I would like to work towards. And I really like that your idea of having those simple spatial operations like intersections and joins and that kind of things, so that if you can simply chain them like this, then you can easily describe that as a data in a declarative way, and then it's rather simple to have the drag and drop UI where you define those transformations. And
you can see my dream too. Yeah.
Yes, exactly. That really resonated.
What I found, though, I just will say, is it seems so simple, but there's so many pieces that come in the way. Like that whole thing about projections, like we have to solve it first. Like I want to just give it. I want to be realistic. Like a year ago, I was like, oh, this is so easy. I'm going to just put some things together. I'll make some great Java FX thing. Well, I'll put all my little transducers into little boxes. I'm not a great programmer, but like I can make it. And then I was like, oh, then there's this, and then there's this. And so that's why I framed it as like, we may never actually write the graphic UI, and that's not ideal, but I think it's okay. Like for now, it's that I would encourage everyone to worry less about that sort of tool, like those chains, the visual ones, and more that there are a lot of building blocks that we have the opportunity to work on making first. If they all get in place the right way, whether it's in JavaScript or Java or whatever, maybe it could exist. And then if that thing were to be made, which exists in no language, that would be a very compelling use case for Clojure in this world. But it is very true that there's a lot missing first. And like, it's like my Brussels sprouts for documentation. There's a lot of things we just need to eat, like our healthy vegetables, to get that stuff in there. And do not be too persuaded by the dream. Like, we have to find the boring things that happen first. But you know, for example, let's say we get all the projection stuff working great in the JVM, like the thing with the C bindings, whatever else. Okay, well, now JavaScript doesn't have that. JavaScript doesn't have the ability to correctly get all these projections either. It's never going to be a fully performant, projection-based way of visualizing things. So there's a couple different pieces that are absolutely missing right now. One, some version of that C bindings version for JavaScript. Someone has to make that. Like, what that means is someone's going to need to, I'm not a very good JavaScript programmer, use Emscripten to compile the C library for projections into some crazy JavaScript thing, and then write a JavaScript library which talks to the SQLite, gets the current whatever string, runs it through the crazy Emscripten thing, and then reprojects your points. I mean, if you did that, you would have an amazing JavaScript tool that can reproject any kind of point. And you get to stand on the back of all the existing amazing projection work in Proj. But you have to do that, right? Another thing, you know, Mapbox only does the web Mercator projection. A good GIS tool actually needs to be able to do all these different ones, unfortunately, even if you never want to, which means open layers, or there's a lot of weird, crazy ways you can like kind of back into different projections in Mapbox where you like fake reproject things into web Mercator to kind of look like another one. Whether it's that to use Mapbox GL or switching to open layers, which can do other kinds of it, like that's an unpleasant vegetable we have to eat first before we get to the chains. And so, you know, I see it there, but I do recognize, like, as soon as you start to open the box, you realize there's a million other pieces we need to work on. I'd love to get going on it, and I'm trying to do my little pieces, but what might even be good is like just brainstorming all the hard things we have to do to make it happen. And then just whatever skill sets everyone has, we begin tackling the chain of them together. That could be the path forward. And I'm not a good front-end developer, so I would love to rely on some of your skill sets to make that happen.
Yeah, like I really like the way how you think that you want to have the profound building blocks, and on top of those, then you can do or solve any GIS problem. But maybe the other way to start thinking about it would be just first support one projection and then start expanding from there, but and get something easily done in the first place. But of course, then you will just eventually hit all the hard problems anyway. But that's like another way to think of it.
And I guess we could also go a long way without having all computational facilities in the browser. We could use Clojure, JVM Clojure as the runtime and just be able to view it, right?
I agree with that totally. Yeah. So all of you front-end developers, I'm going to defer a lot of sort of the decisions about that kind of stuff to you, because I don't know it as well as you. I really do live a little bit more in the analytical side of things, but I want to help however is useful to make that happen.
Yeah, I see it as a spectrum. Like there is the like the very low level, and then there's the analytical level, and then there's the presentation level. And I've been mostly working with the presentation and how to ingest the data, or how to get normal people to understand the basics of GIS and putting the data in and so on. But I'm also interested in the analytical section, because that's where the actual interesting meat of the whole GIS business actually is in.
I will make one pitch for why I'm so focused on trying to make a cross-platform version of all these building blocks and why I think Clojure is useful there. Here's my pitch, which is QGIS is amazing. It works on the computer. Like if you have a Chromebook and you've got your crazy Linux subsystem for whatever, you can get it to work on a Chromebook. Like you can do a lot of things to make it happen. If you run Python and you've got your C bindings and whatever else. But like that crazy thing I just said about the scripting version of Proj and whatever else, like part of also my motivation to try to make sure that the CLJS port starts to happen is QGIS and the GIS world at the moment is fundamentally incompatible with the entire world of mobile devices, which are becoming an increasingly fundamental piece of how people's lives work, tablets, whatever else. And I do see value, and QGIS is never going to do that because Python doesn't run on these things. And again, this is like another one of those dreams in the future, but there is a piece in me that sees the ability to sort of have Clojure work on all the current things. Like you said, you know, it's a spectrum, some pieces of it on the JVM, other pieces for visualization. There's a piece in me that like is really drawn to the idea of utilizing the JavaScript target as a way to bit by bit in sort of a thoughtful method, like get it working in Clojure and just make sure that each one of the steps has a logical way of getting it into JavaScript. That would mean that our entire thought process, eventually, if your visualization's in JavaScript, if some of the analysis can also be in JavaScript, if the projections can also be a little bit in JavaScript, then actually the mobile device can be a thing for GIS too, and not just a visualization tool. That is not important. I don't do that professionally. I know that I'm getting way too up in the clouds here, but just for whatever it's worth, it's the reason why I would encourage our thought processes to try whenever possible to keep to bring Clojurescript along, just because it would actually do something very, very new for the field. That would mean JavaScript development can, and therefore mobile devices can do what is right now really stuck on desktop computers. But again, I'm now getting way up in the clouds, I know, but it's worth thinking about.
Yeah, but open layers works really great on mobile devices. And it has a huge amount of functionality, and it's still under heavy development. So I see a lot of potential in that, and I'm using open layers myself quite a lot for implementing the presentation layer and doing simple GIS operations in the browser, also on the mobile. Okay. But emphasis on the word simple, like drawing simple geometries and splitting them and checking that they are not intersecting and that kind of stuff, but not like the real analysis part. Yeah, but this has been really interesting, and I'm happy that I joined this thing. But I have to leave now. Thanks. Take care.
I suppose we can probably end it here, and if anything, we can take it offline. Right. So yes, thank you so much, Will, for your time and your efforts and like your very insightful thoughts.
Of course, absolutely. I'll talk to you all soon.